The Tiger Wheel sessions, 24th January, session 9. Hey, Isaac, what's up?
Hey, Aaron. It's been a week since we done this, so I'm not remembering exactly where we left off, like exactly where. But I know in general what we're working on. We're working on the manifest level data structure, and this stores all the metadata we need to locate data on disk in memory. And so it needs efficient ways to query and efficient ways to add new data to the manifest level. And this is for just one level of the LSM tree on disk. And where we left off, we just about finished up with the read path here that then queries data from this data structure. Just checking to see if there's anything else we need to do. We still need to check the snapshots. That's our one to do here.
Yeah,
Anything else you're remembering that we haven't done yet for the
I
read
think
path?
I think we looked
Might
at
be it.
it. We spent a lot of time on Iterator Start getting that right. We had this really cool idea.
Indeed.
How do we do binary search across duplicate keys? When we need to ignore some of them because of snapshots and stuff like that, and inexact matches binary.
Right.
And it was getting so complicated. In the end, we simplified. We had this idea: if we're going to iterate in ascending order, then wherever our binary search lands, we will just go in the opposite direction and stop till we get to
Right.
the outer bound, and then we'll shoot back again. So that was really cool.
That's
So I
this
think,
right here,
yeah,
where we take the reverse iterator and then go in the other way until we find the real start key.
yeah,
Um, Basically until we're guaranteed to get a key that's equal to. Well, we get the right start key, but we can have duplicate keys, and so we iterate
yeah,
until we find a key that's not equal to the one our binary search algorithm gives us,
yeah,
and then we stop iterating and go the other direction to start the actual iteration, and then skip because there's not actually duplicate keys in this name snapshot, but our binary search doesn't take snapshot into account here. And so that's why we need to do this.
yeah, exactly. And and then so iterator start. Maybe we could just like begin by like running through the logic again, yet again, just to get comfortable, check that we didn't leave to-dos. But I think we were already finished with that, and we were into
Yeah, I think
skip.
we've gone through this carefully several times
Yeah,
at this point, I think.
yeah,
Yeah, let's just start like one level higher at iterator maybe.
yeah,
There's not actually much thing to do here, but this is the entry point for our read path. Um, Take a snapshot, key min, key max in a direction, and then we just call iterator start right away with the key and the direction.
yeah,
This is wrong. This needs to be key min and key max in direction.
yeah.
Well, I'll fix that.
Cool.
All right.
So I thought with iterator start, just to go over it really quick, not to spend a lot of time, but just to
Yep.
see that we still understand the code, that it's commented clearly enough and it makes
Indeed.
sense after a little bit of break. Uh,
We first just we check if the root keys are empty, so we don't have special cases later on.
yep.
Then we switch on our key to get um, the key we're searching for, depending on the direction. We do a binary search on the root node. We get an exact result. Then we need to do our adjustment iteration, but then we're done already. We pass in relative index 0 then to indicate that we have found, because in the root we store the key min of each key node, and so the index in that key node of the key we've just found in the binary search of the root is going to be the first key in the key node. So we just pass 0 there,
Yep.
and then the index of the key node. That all makes sense.
Yeah, because that's
Then we
going
got the
to
special
be
case.
it's going to be a
Yeah.
key min that's in the root. That's why relative index is 0, and then the node is
Yep.
the actual key node.
Yeah, the index of the key we found in the root, which is the same as the index of the key node.
Yeah.
Then the root has got one key per key node, and it's the
Okay.
key min of each key node.
Yeah.
And then here we've got the special case if we don't have an exact match and the root index result is 0, which means that we've found something less than the 0 index, the key at the 0 index, which means we're out of bounds to the left. This is because that means it's less than the lowest key stored in our manifest level. In that case, if it's ascending, we can return 0, 0 to then start at the actual lowest key, and this may be out of bounds for our range, but we'll do the other bounds check in our loop.
Okay.
So maybe this is then about greater than our max key. We don't check that here. We don't examine the max keys here at all.
Yeah.
You know, we actually could do that check here and then assert in the loop.
Yeah. Yeah, I think so.
Into that?
I think so. The more we can assert here, the better. I was even wondering, like root result exact, if there was anything we could assert there, but I don't think there is.
Yeah, I don't think there is either.
Okay.
But this could clean up something in our loop. Oh, these are asymmetrical currently.
Yeah. Great idea.
Maybe we can exert this actually. No, only we can. We gotta read this comment again.
Yeah.
But yeah, like I said, we can't assert that, I don't think.
We could actually handle it within Iterator Start. We could compare against key max there and then return null. And that way we can then make these two switches symmetrical.
That would be nice. It's not guaranteed. Yeah. Well, that would also make Iterator Start a lot more complex, though. I'm not sure that's the way to go. Because then you've got to... Then right now we just have a very simple equality check in Iterator. And this one, it would be kind of here where we'd have to do it, I think.
Yeah. Well, we'd actually have to do that.
It's not just here that this case arises. It's also down here. It can really happen for any table in the that we're searching for.
Okay.
And that's on the table level then. Then you have to go look at the table. Actually, we don't even look at the tables here either. Here we just we iterate on the keys. Sorry, I'm talking about here. This is level.keys iterator, not level.tables iterator.
Yeah.
And so I think it's probably not going to be the cleaner to do it here. I think it's going to be more complex.
Okay.
And this is just like the comment says, this is the result of us storing only the min key in our indexes.
Yeah. And it's also nice actually to have this because the comment talks about this case now rather than not talking about it and handling it and then having to say why we handle it.
Yeah.
Okay.
Yeah, I think it's nice like this.
Great.
And so back down to here. We can, in the descending case, we know that if we're already out of bounds to the left and we're just going to be going further left to descend, then we can just return null. It doesn't overlap with the search range.
Okay. Yep.
And then in the case where we have not found an exact match and we're not out of bounds to the left, then we go to the key node just by taking our index -1. Because we actually need like the next smaller key node, because we've now found root.index is now like the index of the key node that's like 1 greater than what we've searched for.
Yeah. Perfect there. Nice comments. That assert gives a lot of confidence.
Yeah. Yep. Indeed. We also added a binary search test case for this.
Yeah.
All keys, node elements. Yep. and just another binary search. We've got another assert that's not equal to 0. I love that we can assert these things because it makes the code much less branchy.
Yeah.
Otherwise, we would have needed here a loop like we had before, or like we had for a little bit. And we would have needed here like some branching logic to handle the 0 case especially.
Yeah.
But we've handled that up here instead.
Yeah.
And we can do this -1 because of that.
Yeah, that's
And
great.
then well, yeah.
Yeah.
And then we just do our iteration with the keynote relative index in the direction. We already looked at this briefly, but yeah, I'm pretty happy with this.
Okay. The only thing here maybe is, sorry, Isaac, I'm getting a little bit of feedback, tiny bit.
All right.
Cool.
Hopefully that's better now.
Yeah, let me check. Testing, testing. Perfect. Thanks. So the build to int here, it follows the same pattern above, where we do a -1 and we can then assert. I'm sure maybe we thought
Yep.
about it, but just to double check, can we assert here again that what we are not that assert, just one higher. If we go up, that's at compare keys. Do we want to do something like that after calculating relative index?
Hmm.
Or maybe that's a little bit too.
So let's see. So you could do this in the case. You could only do this if keys are if in the case that it's not keys result.exact. We could do an assert like that.
Yeah.
It would look like this, I guess. It'd be like assert compare keys um, you can only do this if keys or if it's not exact. Um,
Keys relative index, I think.
yeah, keys. We want to compare relative index and sort of that's less than relative
Key.
index +1, I guess, or just result.index. Um, um,
That's it.
yeah, and this is the same or the same explanation as up above.
Yeah. And then I was also wondering, just to double check, like, is this correct? Our less than sign, is that correct for both directions, for descending as well?
Yes, it is.
Yeah.
Because we always do the same binary search. Doesn't matter if we're doing greater or less, or you're descending or ascending.
Yeah.
Binary search stays the same and always does a less than comparison.
Okay. Okay. Yeah, that makes sense. Great. Shall we check out Iterator
Yep,
Start boundary also?
sure.
I like that we've called it key cursor to show that it's into keys.
Yep. For sure.
So we iterated the keys. We started the key cursor, the absolute index for that cursor in keys. Then
Yeah.
key cursor, the node. That's like the hint. And we're going to go in reverse direction to what we're currently doing. Then
Yep.
check that the iterator cursor is equal to the key cursor, so that we're binding the two together. We expect that they've got the same starting position. Then, and we've checked that comment we checked. There's cursor.
Yep.
I think okay, yeah, we've got a naming thing where we call it adjusted equals reverse dot cursor, but actually there it's now just called it dot cursor.
Oh, did we get rid of that? Yeah, we did.
But I actually like the reverse thing, just calling it reverse.
As you like prefer reverse to it.
Yeah,
We can fix that too.
yeah. And then just in our assert, we still call it dot cursor.
Yeah.
There. Yeah, then we capture the start key. We capture the position of the start key before we call next, because next will modify before returning. So we want
Yep.
the position of start key. That's kind of like what we're saying.
Yep. So adjusted corresponds to start key. And
Yeah.
then adjusted next corresponds to k in this loop.
Yeah.
And then if we see that the keys are not equal, adjusted next, so that this corresponds to k,
Yeah.
and then break. Or well, sorry. If the keys are not equal, we break while adjusted next is corresponding to k.
Okay.
I shouldn't have been highlighting this line. That didn't make sense.
Yeah.
But after the loop, we assert that yeah, the start key and adjusted are still equal. Yep.
Okay.
But then
And
the
that's
next key in the loop, or the next key and start in keys in that direction is going to be not equal.
okay.
And that's why we've terminated the loop.
Yeah. Yeah. So,
Yep.
and reverse next will return null if there's nothing more. And that is
Yep.
going across all keys in the key node. I'm just wondering, what if we've exhausted all the keys in the key node? Oh, okay, level
This
keys
goes
is going to
beyond just
go,
one key node.
it goes
This
beyond, yeah.
iterates. This will go to the next key node if we run out of keys in the key node.
Okay. So we could
And
then,
so this can only return null if we reach either the lowest key in the table or the highest key in the table.
yeah,
In which case there's no more keys in that direction to iterate, so we return the last one.
okay. So we could add an assertion that the reverse iterator, its cursor is either right at the beginning or right at the end. But
That's just kind of, I don't know. That's kind of trivial to assert.
yeah,
That's the exit condition of our iterator. Like we go look here.
yeah,
We can also set this early though if we want to.
yeah. Which we don't want
You
in this
do sometimes.
context. Yeah.
No, we don't.
So maybe we should then.
Yeah, it's not too bad.
Yeah.
What we do is just switch direction. Oops. Sending, we'll then assert Dot, what do we have, like, what are the fields of this again? Node and relative index.
Yeah. And oh, you know what, Isaac? I was thinking we actually only want to do these asserts if the while loop terminates with a null. So
Yeah,
we don't,
yeah, I was gonna get to that.
yeah.
I forgot
Okay.
about it.
Okay.
That makes sense for sure. Otherwise, you can't do them.
Yeah.
So how do we do that? It's kind of awkward, doesn't it?
We can just put a else branch on the while off the while loop.
They'll be hit if it doesn't break. Okay, yeah.
Yeah.
And then, well, for the other one, it's annoying that it's not just 0 though.
Yeah.
Actually, is this backwards? Yeah, this is backwards because ascending you'll go off the end. So descending we want the 0, 1.
Yeah.
For ascending, then you end up going off the top end,
We want the
which
last
means
one.
we need to look at, I guess, adjusted dot node count.
Node count.
Keys, node, what's it called? Segmented array. It's node count, yeah.
-1.
Yep. Good catch. And the relative index is going to be, you got a helper for this somewhere? I guess we have, it's going to be, we have to look at basically counts. Or maybe here is better. We're not kind of getting into the implementation details of this stuff though.
Yeah.
So we can just take like node element, the last node, and see the length of that. That's probably best.
Yeah.
We make ourselves like some blocks here because this is getting kind of annoying.
Yeah. It is like messy,
And
but
then,
it's so important that I think it's okay if we cross-check implementations like this and
yeah,
reaching a bit and check.
I think it's not too bad.
Yeah.
Equals, this is gonna be keys dot node elements. Here, keys dot node count -1. And then we're gonna in dot length -1. That's a little bit messy. It's also 107 columns.
Okay.
You want to like just make a helper function that gives you the last element in the segmented array? Should we just like make that a normal public function in segmented array?
Yeah.
We only use here, and this is assert. I think that's probably the best way to do this.
Yeah. We could do it for nodes as well, like return the index of the last node and index of last element.
U32. Supposed to be a T. Ooh, there we go. think that does it.
Cool.
It's going to be called keys though.
Array, and it needs to take in a node index.
Oh, you want to give it the last element of a node, not the last element of the whole thing?
Oh, actually, we do want
Um,
to. We want to do it off the whole thing. Yeah,
yeah. We can also just have a return a cursor here. I just realized that. Um,
that makes sense. Yeah,
we can just
that's
use, yeah, that's probably even better.
yeah,
Um,
much better.
so we also do it for first, just to make it then symmetrical.
Yeah,
So our cursor, well, yeah, we can just call it last, first and last, perhaps, and then
yep,
return, like,
yeah,
I kind of feel like I'm implementing a C++ thing, because they also have, like, first and last for their iterators, but
yeah,
it's
yeah.
not that.
No, then it would be polymorphic as well,
Um,
according to type.
yeah, and for those ones, you also would need const versions and non-const versions, I'm pretty sure. Um,
Yeah, yeah,
you need to
yeah,
have, like, 2 different functions for const and non-const.
yeah.
It's a mess. Um, so we need, this is going to be the relative index. Node equals, yep.
Nice. I was just thinking about that.
Just did, and here, I messed something up here. I didn't close one of my parentheses. There we go. And then we can do first as well, I figure, just for symmetricality, or to make it symmetrical. Um, all right, that should be good.
Cool. That looks really nice. First,
Yeah, this does look much cleaner now.
yeah,
Very clear what the intent is. So you don't have to like think about what the zero index means.
yeah,
And yeah, these are also pretty simple implementations, so it's not that much complexity.
yeah,
We don't actually need the self parameter here, but I figured that we just do it like that to make it symmetrical and just ignore it.
yeah.
Um,
Cool. Yeah, that's nice. Nice like that. Great.
all right, nice. We've added an assert we didn't have before.
Yep. Two asserts, right? Like one further
Two
up as
asserts, one
well.
up here too.
Yeah, yeah,
Should we explain this into the comment? So we'd probably like copy this,
yeah. We
adjust
we
it
could also
slightly.
we could also just comment and say this mirrors the earlier assertion against the root.
Um, yeah, this on That's good.
Nice.
Period.
Cool. How's the line length there?
Right now we're at 101. That's too bad.
We could just do a root keynote comma and drop the and.
Yeah,
So,
that works.
Yeah.
98.
Nice. Okay, so we're back into then the outer iterator where we can start to think about snapshots.
Indeed. Yeah, so now we finished with the start iterator. Now we're back into here, and if it returns a start cursor, then we just go here and we find the absolute index corresponding to that cursor. Then we jump to the correct table node for the key node of our start, and we're off to the iterator. We've got our inner iterator initialized then. Otherwise, we initialize a done. If done equals true, inner iterator.
Okay.
And then we return that as part of our outer iterator.
Yeah.
And the actual iteration happens here. It's our to do, and so, but assuming that we always if we always match the snapshot, we just take inner.next, get the table info from that, then we check if we're out of bounds. If we are out of bounds, we set done to true and we return null. And then if done is true on the next iteration, this will always return null, and we'll return. Well, maybe we need to return down there.
Yeah.
We'll return null then.
Yeah. Isaac, I was wondering if we can do an assert on inner.done. Like, what do we expect here with respect to that?
It should not be set yet, but.
Oh.
Oops. But other than that, yeah, I'm not sure if we can assert anything else.
Yeah. We could actually assert this always in the loop, right at the top of the loop.
True. Yeah, just. And then also, like, we assert the is done here, I guess.
Okay.
Just for completeness.
Yeah. We could group those two together if you think, but if you want it separate, it's fine. Like how you had it the first way.
These two? Sure.
Yeah.
It's fine.
They're kind of grouped up top as well. So, and is that always what we expect when we, like, what if, will inner.done get set to true if we just run out of stuff?
It will, yes. Here, if we run out of stuff in one direction, we'll set done to true.
Okay.
That's if cursor.node becomes the last node. Is this right? This -1?
Yeah. Yeah, because node is an index. So that's correct, the -1.
If it already is, so we've already checked the relative index. Okay, yeah, that makes sense. Cool. Then we set done to true, and same thing with the other direction. If we've reached the first element of the first node, we set it to done, and then we return element. And then on the next iteration, we don't return anything.
Okay.
Oh, so that's actually, we can't do this assert then. This one doesn't work.
Okay. Why not? I missed that.
Because when we reach the last element, we set done to be true before we return the last element.
Okay.
And then if done affects the next iteration, not the current iteration.
Okay.
Um,
Okay. Cool.
we have to just trust that we've got it right here, I guess.
Yeah.
I think pretty sure we do. This is nice and symmetrical.
Yeah.
It really helped to make these things have the same control flow.
Yeah.
To make sure that they were right.
Yep. I think this should go into Tiger style doc, like the principle of making where the actual function of the code is symmetrical, then the code should reflect that and be symmetrical also.
Yeah,
Yeah.
indeed. Cool.
We could also do in that other iterator we were looking at, we could assert that when it's done again, like we're at the cursor we expect.
Yeah, it seems to be. I got distracted by something here.
Okay.
Um, this is not going to compile because node is not in scope. I think this should just be elements.length. That's what we should use here.
Yeah.
No, it doesn't work though because we want it to be the length of the next element, of the next thing. So this should be like it.cursor.node. That'll
Okay.
fix that. Yeah.
Good
Cool.
catch.
Sorry, what were you saying?
No, that's a
Um,
good catch.
well,
Array
it would have just
counts.
been a compile error, but now it's fixed. Um,
Yeah. Okay, cool. Yeah, I was thinking that outer iterator where we were at, if we go back there, where we had that assert that we've just removed. We
yes.
So here we break out because the keys are now out of range, and otherwise we're going to break out because we've hit the end of what we've got. So
Yes.
so we could then again have a else branch that we double check the inner.next is working correctly by checking that the cursor is either first, or we can just copy what that switch we had on the other while loop.
And we actually can't now because if we go out of range here, we're not breaking from the loop, but we're returning null and setting done to true, which means that next will then return null the next time this next function is called. And so you'll hit
Of
the else
course.
branch then.
Okay. Okay, cool.
I think this is as pretty much as good as we can get here. I think this iterator is not too complex. So I think I'm not too worried about this returning or we're us messing up the null check here. We can't assert here that it's done either because we allow like setting done as part of the API. We use that here too, where we
Yeah.
set done early. So I think this is as good as we get for that. But should we add snapshot support now? Or is there anything else you want to look at first?
Um, yeah, I just wanted to understand better the reason we can't assert that we are not done at the top of this loop is because next may return a table info and set done as well. So that the
Yes,
next iteration.
because the state stored in inner is for the next thing it will return.
Yeah,
Um,
yeah.
Same thing with the cursor. That's why we needed the adjusted next and adjusted. Because
Okay,
the state as part of the inner iterator is always we always like capture a table info there and then adjust the state
okay,
essentially.
okay.
The first thing we do is get element but using the current state. Then we adjust the state. Then we return element, which corresponds to what the state was before next was called.
Yeah,
Um,
cool.
which is a really clean way to implement this. I think it's
Yeah,
much better than doing the other way, where you then like increment and return. Because then you've got a special case at the first iteration where
yeah,
you can not increment if you are already if you're just starting off or something. It gets tricky.
yeah.
Um,
And we ran into that. We were trying to use we were trying to use the index for more than one purpose, not just to index into stuff, but also as a way of knowing when we finished. And that was just getting crazy. So yeah, maybe we can just put a comment there and say we cannot assert that done is false because inner.next may set done before returning an element.
See also that we need to like here actually set or say it's.inner.
Good, good.
Yeah, okay, inner.iter, it.inner.done equals false as
next may set done before returning.
Yeah.
That comment is good because if I come back and read it later, that would be the first thing I would want to do is go add these asserts back in.
Yeah.
Yeah.
I agree.
Nice. Okay, so now
Cool.
we ready to check snapshots.
I think so, yeah.
Yeah.
And so it should just be a pretty simple comparison between, so table info has got to have a snapshot min and snapshot max now, I think. Or is it, what do we call it? It's an LSM tree. Const table info. Yeah, snapshot min, snapshot max.
Yeah. And they're always disjoint. They never overlap. So yeah.
Yep.
Cool. I think
So
also just
we
to
do an assert.
okay, you go for it.
It's just an assert I thought we could do right away.
Yeah.
Get rid of that. Okay. Yep.
That's a great assert. Yeah.
And then we just need to check if our snapshot's in range. So, if snap, so that's the thing to do is check if it's out of range, and if it is out of range, then we continue the loop. If it's not out of range, then we fall through to the switch. So if snapshot or it.snapshot is less than table info.snapshot min. I think we want to assert that it's not equal, right?
Yeah.
Because you're gonna say that you snapshot things can never be equal. So we'll add that in just a second. Continue. Otherwise, assert it.snapshot is not equal to table info.snapshot min. And then do the same thing for max. Except with greater than instead of less than.
Yep.
And then I think we've got it.
Yeah. That's very nice.
Okay,
Yeah.
what about the case where we say we pass max in 264 -1? We did think of this. Nice.
If there is no snapshot, we'll pass it very high.
But not exactly max, because what we do here is we set this to max in U64 in creation. But because we assert that they're not equal here, we can't pass that here. We have to instead pass -1.
Yeah. Wow. Cool. And we're going to handle it elsewhere if we've run out of U64 space for snapshots. In like a few centuries time, you know?
We're gonna say that's not our problem, I guess.
We could panic at that point and say like, you know, Doc Brown says hello to the future.
Yeah. That we can do that. Just do that in our ticker thing.
Yeah,
Um, yeah,
yeah,
I think we should have panic for those cases.
yeah,
Um,
yeah.
and say, yeah, have fun. I feel like slightly guilty about it, but I think people won't be using this anymore in 100 years. Definitely not. We'll have something new by then, I'm sure.
Yeah, no,
Um,
we know our limits, you know, like how long we expect it to run, or and when we hit the limits, then we hit
yeah,
the limits. So, yeah, nice.
it's not as bad as like the 32-bit time stuff that we'll be hitting in 2038 either.
Yeah,
Um,
yeah, that's going to be interesting. Yeah, maybe
Indeed.
maybe if my daughter's doing some coding, she might uh, work on that, you know. But I don't want to
Yeah,
prescribe. I won't prescribe anything, but you know, but it'll be the next generation. Like, oh, actually, we'll still be around
yeah,
too, right?
yeah.
2038,
We'll still be around.
20 years.
Yeah,
Yeah,
it's another. Yeah,
yeah, cool. So we'll just
it'll be
put that
fun.
on,
There'll be lots.
put
There'll be so many bugs.
put it on the to-do list, you know.
Yep.
Cool. Shall we just add some like shall we separate the min and max checks over here?
Sure.
Like that. Yeah. And I was wondering if we do actually return the table info from this loop. We
We do
we
right
do,
here.
yeah. Okay.
There might be a better way to structure this. Um, hmm. I'm not super happy with having like the re yeah. It seems like we more like iterate like, wow, this is true. Um, we want to iterate, and then once this is not true, we want to just return. Um, but then we also want to have this done here, so that is kind of nice.
Yeah.
Um, it's not bad. It's pretty clean.
Yeah. We do want to have those asserts also.
Yeah. And having it split up between these two conditions is a bit cleaner. It makes it a little bit simpler to read each one.
Yeah.
We could also do like a one if statement which checks both the bounds, and then inside the if statement put this stuff
Yeah.
with the return. But then it also just gets more indentation, and this check gets has to be made into one check instead of broken into two simpler ones. And
Yeah.
so
Yeah.
I think it's a pretty nice way to write it actually.
Yeah.
Um,
I also like it because it's the other way is also nice because we're stating stuff positively. So we're saying only if this is all met, then return something. Um,
right.
so in a way, in some cases, that approach can have more safety because it's saying exactly what we want, then return. This
Yeah.
one, this one I also like though because there's a few more cases here where it starts to make the condition like quite compound. So then it's also nicer where you just try and fail early, like the slightest thing off, continue, you know.
Yep.
But okay,
I think
then
this works.
again,
Yeah.
yeah. So I mean, maybe sometimes that can be bad because we don't want to skip data either. That would be wrong. So
Yeah.
uh,
We aren't skipping data here. I'm
no, no,
pretty
yeah,
sure. At least not with these two checks.
no,
No, these are right.
yeah. Okay. So now, what do you think? Have we reached level zero's stage?
Yeah. Well, no, we haven't. We've finished now. Now we need to do a commit, I think, like an
Yeah.
actual nicely worded commit. Well, we don't
Okay.
have initialization here. but that was kind of as part of the write path, I think. Because now we
Yeah.
need to do the write path for this data structure. I think it's the next big thing before
Yeah.
we get to level 0.
Okay.
Um,
I
the
was
read path,
thinking,
it seems pretty solid now.
okay.
Um, Go ahead.
I was thinking, well, since we've got binary search loaded in our cache and we've been thinking about all this stuff now, maybe we could just explore, like in a separate tab, just as a note, like some scenarios where we couldn't make this handle level 0, or maybe we could see we could actually handle level
Oh,
0 overlapping ranges here.
right.
Uh,
I remember this stuff now.
yeah.
Yeah. Let's see what that looks like. Shall we do a commit first, though? Um,
Okay. Yeah. Yeah.
we've got now 4 WIP commits. I'm just gonna squash into one. Get the right path done commit. I think there's also like some file we don't even use anymore.
Yeah.
Um,
We created like a whole lot of different files for this.
uh, else we have here level tree and manifest level. Um,
Yeah.
yeah, so one of those is not useful. Is it level tree? I think 'cause right now we're in manifest level. It must be level tree that's not useful.
Yeah.
So
Oh, there's our div seal, by the way.
sorry.
Before you delete, we want to just capture that div seal.
The div CL. Oh, this is
Yeah.
manifest level. This is already good. That's
Oh,
in our
okay.
level, our manifest level.
Okay, cool.
We might want, if you know a better way to place to put it, we can do that too. But right now it's just there.
Yeah.
Level tree is here. It also has the div CL and it also has a manifest level, but it's not complete. It has
Okay.
these. It was back when we had nodes like
Yeah.
this,
Yeah.
um, and we had really funky. Oh, look at that! That's our XOR link list.
Yeah.
Pieces.
Yeah.
All right. Goodbye, manifest. Or all
Level
right.
tree.
Search. Dash level tree. All
I've
right.
been I've
It's
been
still alive in the
wondering.
Git history for now.
Okay, cool. I've been wondering what we can do for. Have you tried rubbing a database on it? The conference, Jamie Brandon. Uh,
Yeah.
like thinking LSM Forest, and I've just been wondering if there isn't some kind of int reference from Lord of the Rings we could use. I don't know.
They are very.
Uh,
They're very old. They're very slow beings when they're
yeah,
you get them going and they tear some stuff up.
yeah. I don't know what you think. You and I, we must work out what we're gonna do and like all the points we want to
Yeah.
cover.
I'm not sure
Uh,
how much time. It's a very short talk too, so I'm not sure how much time we have to make references, but
yeah, yeah.
um, we can find
I,
something pretty quick.
I thought of something as like an image, as like a cover or a.
Yeah,
But we've got 10
that
minutes
makes
max,
sense.
so we'll have to work like triple as hard because we'll have to condense everything. Like
Yeah.
we'll just have to compact it.
Well, um, I don't know, 10. Got like 5 WIP commits now. Okay. I feel like we should also fix the date on this commit to make it like today when we actually commit this. Um, all right, let's do the actual commit now. So this is now LSM implement the write or the read path of manifest level. All right, what do we want to say about this?
We could say read the Twitch notes, or read the descriptions for these videos on YouTube.
Yeah,
Uh,
efficient in memory storage for our table.
Table infos. Yeah, for table
Yeah,
infos.
table info metadata. Let's see. It is built upon or built on fixed size nodes, a pool of which will be shared between all trees in the LSM forest. We talk about LSM.
Yeah. LSM dash forest. And
LSM
I've been doing
capitalized forest then?
yeah, I've been doing capital forest. Sometimes people do LSM tree lower T, but I just think it yeah, it makes sense capital like that.
All right. Anything else we need to share here?
The big idea is it handles snapshots already, and
yeah.
but
Yeah.
maybe yeah, maybe that's okay.
Or we can just say like the query interface.
Mm.
Handling snapshot.
We could actually say skipping over snapshots that the query cannot see.
Over, well, it'd be skipping over for tables that
the query cannot see.
don't match the current snapshot.
Yeah.
Query snapshot.
Yeah. Cool. And then skipping is just a double P that it needs. Yeah.
Anything else? Nope.
We
Everything else needs to be spelled correctly.
We could just say to do handle level 0 overlapping key ranges.
Yeah. To do level 0 with its unique property tables.
Yeah.
Or just say.
That's great. Yeah.
Look good to you?
Yeah, awesome. Nice comment.
All right. That's a 600 line commit.
Wow. Nice work.
That's like the last, that's like the last 2 weeks of work we did.
Yeah. Not bad, hey?
Yeah. I guess a lot of that was also like writing and planning though.
Yeah.
And rewriting code a lot of times and
Yeah.
reworking our spreadsheets and whatnot.
Yeah. Yeah.
Yeah. Cool.
Awesome work,
So,
Isaac.
level
So I was wondering, like I had a hunch, maybe we could use this snapshot skipping over technique to handle level 0 if we integrate a little bit with how our binary search works and if we take care to sort the table infos to help us out for this. Just a hunch, but I was wondering maybe in a tab we could come up with counter examples for why it wouldn't work.
Okay. And so let's just remind ourselves like what level 0 means. That means that the key ranges of tables can overlap. So that means that this check won't work. Like you can't stop iterating when you see the first table.
Yeah.
outside of the key range.
Yeah.
You always need to look at all tables in the level, or when can you stop iterating?
The trick is to kind of see level 0 as a stack. I think if I understand stack correctly, level 0 is like it's got multiple levels in itself. It's like geology, and you've got
Hmm.
sedimentation layers in a rock face. You know, you've got all these sedimentation layers. Some of the sedimentation layers overlap, some don't. So you basically, level 0 is you've got the latest stuff and some stuff that overlaps that isn't as new, and then down there, and then gaps, and that's how the whole space looks. Or maybe like the newest thing in level 0, or the earliest key in the key range is the oldest thing, and then there's something newer but further that overlaps. Um, so it's almost like
So
you're playing like a 2D game where you jump from platform to platform, and sometimes the platforms overlap. Does that make
yeah.
sense?
So what does the right API look like? Like, what does a range query mean on level 0 then? Because the tables we return, like, you won't be able to iterate every table or every key in order, will you? At
We
least not
we
too easily. 'Cause you'll have to like iterate all the tables at once,
yeah,
potentially.
yeah, yeah. We do have to be able to do that, but it's more. So it would look like a range query at level 0 would look like we say, okay, this is our key min over here. Then we look at like our 2D game, and you've got all these platforms at different heights and some overlap. We'd look at our key and we'd
Yep.
say, well, what's the highest platform that is also earliest for this key? Or if there's one lower, like it's older, but it's first, then that's where we start iterating. So we're going to iterate down and then jump up and then down. And where they overlap, we want to take the one with the highest snapshot.
Okay. And so we look at the age of the table, iterate first based on that, and then so I guess for like a point like we want to query like two things. First, we find the small the youngest table or the old I guess the youngest table, the most recently updated table that matches the key range, and then um we check if the key is there. I'm just thinking about a point lookup first of all. If it's not there, then we go to the next youngest table that matches the key range. Keep doing that until you don't find a table that matches the key range.
Yeah,
Um, and
that's
then
it.
range queries seem, yeah, that's that. I think point lookups are not too bad. It's the range queries that seem like much trickier. Um, because then you really need
Yeah,
to be iterating like all the tables at once potentially, if
yeah,
they all match the key range,
yeah,
which is kind of like what we do in compaction, right? We
exactly.
have the iterator per possible table.
Yeah,
Um,
yeah. It is a k-way
yeah,
merge. It is a k-way merge. But we, the problem, okay, no, it's not a problem. It's a k-way merge where we don't really know the number of streams going into the merge because that depends on how many tables are. But we can put an upper limit on them because we do
yeah,
limit the size, we do limit the count of tables in level 0. Uh, if
yes.
we look at the problem from another angle, we could also, because I do want to see if we can try and use this code without doing the merge. Uh, if we can, maybe we have to use the merge, but it would be nice to have some use cases like counter examples where we show why we can't use this, even we've really tried, so that we don't need to do the
So
code
isn't
for
the
do.
merge the Cantor example? Um,
Yeah, but I just thought like in a like an editor tab, we just show some actual worked examples, then we'll understand it even better. I would just like to understand it myself, just to work through
Sure.
that. But
This
what I
also
was
like
thinking, like we can do like good cop, bad cop,
yeah.
like good cop. We
Sorry?
try and we could try like good cop, bad cop, or I don't know if that's the phrase, but it's kind of like devil's advocate and angel's advocate or whatever. So we want to see
Yeah.
like how could we make it work if we can tweak it slightly on the sort order. Can we make it work using the same code so we don't increase our surface area of code and risk? Or like devil's advocate, like here's a counterexample, we just can't solve it. So now we're convinced. Um, yeah. So on the angel's advocate side, what I was thinking is if we view our 2D game of platforms, and let's say the platforms don't overlap, how would we, like that's very easy now. So how would we solve that? So level zero, the tables don't overlap at all. Then it's just
You
a
need anything
question
special then.
of key range, right? Yeah.
Yeah. Then
Okay.
our code works as is. It already handles the case where tables don't overlap.
Yeah.
They do overlap though. I pretty quickly see some cases where you have to backtrack though, because
Yeah.
um, say you've got two overlapping tables, and well, I guess I could write this out in an example. Um, let's see how -5 is not like a real table. Let me get rid of this one. So you go 0 to 5 or 0 to 7. Then we got or like 3 to 10. Say we got that. Those are our two tables.
Shall we show
And then you're
this?
searching.
Shall we show the snapshot or time as an alphabetical letter at the front of that tuple? So like
But
it,
yeah, so like I don't know, like T or like maybe you call it just like T.
we could even just inside the tuple, we could just put A, and that's an early snapshot. B is a newer snapshot. A comma 0
A.
comma
Yeah,
7.
sure.
Yeah. Okay.
Yeah. I'm not even sure I don't think that even matters for this example I was gonna give though, because
Okay.
um let's say we're looking for the key. Well, let's say we want to iterate, and we're looking for we're kind of looking for the lowest key, and so we hit 0 here, and then the next key in this table happens to be 6, and then 7. Um,
Yeah.
and so we'd have to then return the 0 from here. Then we have to go here to get 3 and 4. And we have to come back here to get 6 and 7. And then
Okay.
we'd have, and so you don't have any, there's no linear scan anymore. You've got to backtrack to do
Yeah.
iteration.
Yeah.
And so I think that it totally goes against what the code we have there is doing.
Yeah. Okay.
Um,
Yeah. Well, I agree.
yeah, you need a K-way
Yeah.
merge. That's the algorithm to do this.
Yeah.
Um,
Yeah. That's a good example.
so for point lookups, that would work fine, I think, as long as you sort by snapshot. Um,
Yeah.
or
Exactly.
maybe even not. I'm not even sure if that would work fine. Because we'd have to then, yeah, it makes point lookups more complex too, because the overlapping nature. Then instead of having like one correct table to find when you start iteration, you
Yeah.
now have, yeah, it just makes
It
everything more
it
complex.
it
And
it
if we can't
wouldn't
use it for KY merge,
it wouldn't work for point lookups either because if we're looking for three, well, if we're looking for, say we're looking for four,
yeah,
okay, well,
yeah, we
it,
have to
it,
look at every table in order
yeah,
of the snapshot that
yeah,
overlaps until we've seen all of them.
yeah,
Um, and so that could work if you had them sorted by snapshot. You would then look at this one, check here first, then check here, then check the next one, and so on. So for
yeah,
point lookup, it might be okay, but because we have to do a different separate thing for the range query anyways, I feel like we might as well just keep the complexity out of this code. It's
Yeah.
already complex enough.
Yeah. Exactly.
Um,
Yeah. So are we going to do then k-way merge for range queries and point lookups?
I'm not sure how point lookups will work yet, but I think probably it's simplest to do it that way. Yeah, because
Yeah.
then we can use the same. It's like here our plan is to just use the range query interface to do point lookups because it's just
Yeah.
like an iteration where you just stop right away.
Yeah.
Because the start iterator, this is how you do a point lookup, this iterator start function.
Yeah.
And so we just expose the same we can wrap this with the point lookup interface perhaps where we pass keymin and keymax as the same key.
Yeah.
And have like a wrapper interface, but it'll just be doing this and calling iterator.next once and returning that or null.
Yeah.
Um,
I was thinking that exactly, and that's nice because then we just have a single code path. Uh,
yeah, we probably want to use yeah, we can use the max direction because that makes it's a little, like slightly cheaper because we have more asserts here.
okay.
Um, that's not really relevant right now though. But yeah,
That's a good
um,
idea. Yeah, that's a good idea.
yeah.
Whenever
So
the
that's
idea pops up, it's relevant. So that's cool. It's like the way of these things, we think of other stuff, or
yeah, yeah, yeah,
then you just write it down.
for sure.
Yeah. Okay.
So
So
yeah, I
we,
think we need something different for level 0.
yeah.
Um, you want to look at that first or go into the other direction for here? I think it's probably better to like keep them the same data structure for now and like do the right path to these segmented arrays.
Yeah.
Um, that's cool with you. I think level
Uh,
0 is not
yeah.
going to be too hard. That
Yeah.
one doesn't have the same scaling requirements.
Yeah. I'm also wondering whether we can't like brute force it a little bit over there.
Yeah, I think we probably can.
Yeah.
That's what I was thinking. Because
Yeah.
yeah, we might not even need gateway merge. We might just have like yeah. Well, we'll see.
Yeah. Oh, just while we're on the subject, what we could do is we could split tables. So I don't know if it's a good idea, but what we could do is when tables overlap, we then split them. So you
No.
get multiple table
Hmm.
infos for the same table, and then that way everything works.
Doesn't that like allow like potentially like unbounded fragmentation though? Um, like can't you like end up with then one table info per key on disk?
Yeah.
I'm slightly confused. I'm not sure how that works.
Yeah, I don't know if it's a good
Um,
idea. It's just one
yeah,
way
I
to
think it's
do
def
it.
yeah.
Yeah.
It's interesting for sure. Um, yeah,
Okay, cool. Let's do the right path here.
cool. Um, yeah, to make this efficient. So I guess when we writing like in bulk mostly, I think we want to optimize this for like bulk writes. I think is
Yeah.
that right?
Yeah.
Um, like reading from disk, and then we're also gonna have to rebuild this when it gets mutated, right? Is that what we
Yeah.
decided on?
Yeah.
Like in
I
order to mutate or to insert tables, we were just gonna rewrite a bunch of this stuff, I think.
Yeah, I was
Um,
thinking we just modify the tables segmented array. We modify that however we like, and then we have a separate rebuild function which the user can call it the end, which will then rebuild the keys segmented array. Just very simple logic brute
okay,
force.
and
Um,
rebuild the root. Yeah,
yeah, not even trying to do incremental rebuild because that will be complex, very tricky.
yeah.
We just brute
And so
force the
I
rebuild.
guess I guess our strategy here is then have a one function or just like a way to build the segmented array. First of all, we don't even have that yet. We need like the first like the low level machinery to insert stuff to a segmented array.
Yeah,
We don't have that yet. And then we need like a rebuild function that takes it that once the table segmented array has been filled up, builds the index or
exactly.
builds the keys in the root. Yeah.
Yeah, yeah. Yeah.
Yeah, and so here we just need a way to insert stuff into our things. We don't have it
And
all yet. We don't even have,
we've I think already worked out the worst case that if we brute force rebuild the index, it's not going to be that long. And
yeah,
we can always,
I agree.
yeah, we can come back later and optimize that. Uh, but that'll be
Yeah,
really, if we make the rebuild incremental, that could be really tricky to get right. I don't know how you feel. I don't,
indeed, yeah.
and unless you think we can do it, and we should just do that straight away so that we don't have debt. Uh,
Yeah, I think that's gonna be really hard. Um,
yeah.
I think it also
Uh,
won't save all that much time. 'Cause I think you're always gonna have the worst case, rebuilding the whole thing if you need to shift everything.
yeah.
Like if you insert to the very first element in the manifest level, you always have to rebuild the whole index then.
Yeah.
I think you already have that worst case, and so I think it's probably not worth it to, um, yeah, you'd at best get like a
Yeah.
you at best cut the average case in half. I think that's
Yeah.
my intuition. I'm not sure if it's right or not.
Yeah. Yeah.
Um,
Yeah. I think so.
um,
And I also think it's not what
so
we want in terms of safety, because it's
yeah, you want one really
extremely
fast.
complicated for not much gain, and we actually want a simple constant time. You see, it's also kind of nice if you know that you always rebuild, then you know, well, it's just constant work factor.
Yeah, well, I think the inserting to the lowest of the tables will be not constant time. They'll be yeah. It might actually not be too bad to do incrementally. I forgot how segmented arrays work. Because when you can insert two nodes in the middle without incurring the whole. You don't have to shift everything. You only have to shift like the node you're actually inserting to potentially.
Exactly.
And so yeah, I think rebuilding might not actually be that bad.
Yeah, you mean
Or yeah,
incremental rebuild.
yeah, it might not be that complex. We'll see. I think
Yeah.
first thing to do is to get I guess do we do insertion first or
Yeah, insert.
hmm.
So we want to drop into segmented array where we are, and then do insert and remove. Those are the two things we need.
Let's just take an absolute index, I guess. Or no, I guess they need to be in sort order is what it needs to be. Um,
Yeah.
but to find the sort order, we want to do like a query to find the spot, right? We don't want to scan. We don't want to do a linear scan to find the insertion point. What we kind of want is to well, we want to use a segmented array cursor. We want to have the start position again.
Yeah.
We're gonna want start iterator as well, again, like iterator start. We want to give us a segmented array cursor, and so I think this insert function will take in a cursor here. I think,
Yeah.
um, and so then
Exactly.
the
Yeah.
machinery above this will do the same iterator start function to give us a cursor. Then we'll insert at that cursor.
Yeah.
And so I think what we first we want to do is here implement the insert function that just takes a cursor and inserts the element there.
Yeah.
Um,
I also think we like the insert shouldn't do shouldn't also be responsible for finding the index to insert at. The user should be given the opportunity to already know where they want to insert the absolute,
yeah,
like the logical index. Because when we do compaction, what will happen is we'll know, okay, we're going to create the the output table is going to be one level lower, and we're going to know roughly where to start. And what will happen is we'll output a table, output another table. We can output multiple tables from that index. So we'll just do take the cursor plus one and keep inserting into the segmented array.
can we like insert a slice then, or I don't know. Will the tables be contiguous? Like, is there a guarantee we can't?
Yeah, they'll be contiguous. Yeah, yeah,
Okay, yeah.
So that might be very useful actually to be able to insert a slice.
Yeah, I think we probably
But
want that.
but I think we can expose that to the user, but internally we shouldn't worry about it too much to start and just think of it as inserting an
Okay.
element, a single element.
That's where I keep things simpler as we figure out the requirements of this data structure.
Yeah, yeah.
Um,
And then the outer
yeah,
interface would be great that you can just insert a slice at an index. That's perfect.
cool. Hmm.
Shall we
Yeah,
take
so
a 5 minute break? What do you think?
sounds good to me. Yeah. See you back in
Like,
5 minutes.
yeah, awesome. Hey Isaac, we're back on.
All right, cool.
Nice.
I guess the algorithm we're implementing is now just to kind of do what this comment says and say, well, never mind. We need to like divide the nodes in half. It's not in this comment, but we need to divide the nodes in half when they get full
Yeah,
and handle that splitting of nodes.
yeah. And then add like as many edge cases as we can to sometimes bring nodes together, like merge them again to prevent fragmentation. Yeah,
Indeed, that's good as well. Um,
yeah.
that's more on the deletion path though, I think. That's where we want to try and merge stuff.
Yeah.
Insert path, we may not need to merge things. I'm not sure.
We could
Um,
sometimes like what can happen is you've got a node, we can't insert into it, so we split it. But by virtue of doing that, that means that the split, now the smaller one could actually merge into the previous one because it's
hmm.
now smaller. Um,
Yeah, we can check for that. That makes sense.
yeah, yeah. Just little like little fixer-upper things. Uh,
Yeah, because those are the two cases where you can make a node smaller. So when you remove
yeah,
something from it or when you split it.
yeah,
I guess splitting it may actually be more common to actually allow us to merge stuff then, 'cause it's a much larger change in size.
yeah,
Um, but we need to handle both of those, I think. Yeah, cool.
yeah. Shall we
Um,
do like a insert function that takes the array and takes a cursor and takes us a slice of table infos, and then we're going to just copy the slice.
um, can we always, we also need to ensure that these things stay in sorted order. That's the part I think
Yeah,
it might be tricky. Um, so if we mess that up, then our search functions no longer work, and we'd lose data
yeah,
essentially.
yeah.
Um,
So what I was thinking
so
is our insert function takes a cursor, so it allows the user to know that it's inserting in sorted order, and then we can assert that that is the case, that the cursor is correct at
yep.
the correct start point, and then we can also uh, hmm, I'm just wondering if we pass in a slice, if the end of the slice maybe might be after another table.
Yeah, that's what I was also thinking. It's like, how does the slice insert work? It seems more like we want to just do should we solve it for like single inserts first and then
Yeah,
slice?
I think it might be like outside of level zero, it will be fine because we can say like if you insert a slice, we can document and say inserting a slice, the beginning and end of the slice can't overlap other, and we can just assert that that's the case. And that will be the
Okay,
case
yeah,
for anything above level zero or anything
cool.
below level zero because like so for instance when we compact into level 3, the compaction is already going to select tables in level 3 that overlap the range. So if there is any overlap in level 3 that we're outputting to, we should have already dealt with that in the compaction. Yeah,
Yeah, that makes sense. Yeah. Yeah, that makes sense. And so there should be no overlap.
no,
Um,
yeah,
and so then inserting a slice is definitely the right API then, because then we can make things a lot less branchy and just be more efficient, because we only then do one split if we need to. If not, we don't do a split.
yeah, yeah, exactly.
Yeah.
We don't have to save time. I thought we could just do the public API could be insert a slice, and then we just literally loop over that slice and have an insert individual function.
Okay, but then we can like come back and change that though when if we
Exactly.
find a way to optimize it. That makes sense. Cool. That sounds
Yeah.
good to me. So let's write that up now. I guess we'll just kind of do a whole like another section of this. We've first got like the read path here, all
Yeah.
those functions up there, and maybe, well, should we do insertions first, like in the file? I don't know.
We could
What
actually.
makes more
Yeah.
sense?
Yeah. Yeah.
Yeah, it seems actually logical. Okay, let's do insertions here. Function. Um, so insert. Taking an array. Self. It's gonna take a cursor. And then it's going to take a slice of t. And can this return an error? Well, no, it can't because we need to actually have the set where we can acquire nodes from as well.
Yeah. Yeah.
Do we pass that into insert? Is that how we do this? Like pass a pointer to a node pool?
Yeah. Yeah. We want it to be like unmanaged. So we'll pass a pointer to a node pool.
Okay. This is gonna be um, items. Oh, maybe that should come first actually then. Node pool. It's just an
Yeah.
imaginary type for now.
Yeah.
Um, we've had
And
those before. I
maybe
think it worked out well last time. Um,
exactly. Yeah. Yeah. Shall we, instead of items, shall we say elements like we do?
sure. All right. And then,
Oh, sorry, Isaac, just one question. Like, do we want to use Zig's allocator pattern for our node pool, or and then have errors if you try and get a different size, or is that going too far? Like, we want to actually have a more specific interface.
I think we want a more specific interface, like that just as fixed size, because we only want fixed size
Yeah, yeah,
blocks. Where it is an
yeah, and
allocator, but it's a very specific allocator. It's a pool allocator, is what it is.
yeah,
Um, And so I think that we
exactly.
don't gain anything by using the allocator interface because we always want it to be a pool allocator. We don't want a
Yeah,
generic allocator. We just want this
yeah.
very specific allocator.
Cool. No, I'm
Um,
with you. I'm with you. I just wanted to pose it, and then we decide, and we know
yeah, yeah,
it doesn't
cool.
make sense also because we're not offering alignment custom stuff, and also it's got different failure modes. We don't expect it can fail. Like it should always have something.
Yeah,
Yeah,
yeah. We're gonna panic if it fails essentially.
yeah, yeah.
But that panic will happen inside the node pool. I think we don't have to worry about that
Yes.
here.
Yeah, yeah,
Um,
yeah. Okay, great.
yeah. All right. And so
And that'll be
what
a
are we doing
pointer
next?
to
We
a
go.
node pool, right?
Yeah, probably. Um, oops.
So now
Um,
first step is we jump to the node. We see, does it have
yeah. So we
space
look at
for
cursor.
these?
So
Actually, we probably want to actually loop over elements and then call insert.
okay, yeah. So this is gonna be insert slice.
Yeah,
And then here, this one can just be very simple for, it also needs to be mutable.
yeah. We
Insert
can actually,
node pool. Well, oh, we need to increment cursor as well, don't we? Um,
yeah, good. Yeah, we do. And we have
hmm,
to do it in a way
this
that
is
takes into
tricky.
account what we've
Um,
inserted. Yeah,
we probably want to use an absolute index here instead of a cursor then.
yeah,
Should we just roll with that for now and see if that works out?
yeah, yeah. I think so too.
We have cursor to absolute index conversion already too,
Yeah.
which is 01, I believe. So yes, and
Shall we call it insert elements so that we've already got this idea of node elements, and then we could have insert elements.
yep, that seems good.
Yeah.
Element. There we go.
Cool.
Okay.
Do we need, when we do our for loop, the way we capture element, we don't have anything of copies there. Hey, that's not an issue.
We do copy it, but yeah, it's not an issue, I don't think.
We're supposed to only copy it within insert element. We're going to copy it into the actual node. But I'm just wondering, in
Yeah,
our
so
for loop,
you want to pass your pointer to an element then?
yeah. It doesn't matter in this interface because we've discussed this many times, because here the compiler will
Yeah.
decide. But I was wondering more
We'll
in
do
the
the
for
same thing
loop.
here, really.
It will.
Yeah,
Okay. That was
it's the same semantics as this. Yeah.
okay. And
LLVM
so
will
would
be
it?
happy to not copy for us here. It'll leave that.
Okay. Okay. Cool.
Pretty sure, yeah.
Okay.
What's going to happen essentially is that this essentially gets lowered to a loop where you index into the element pointer.
Yeah.
This will kind of be replaced with an index into this elements thing.
Okay.
And then you essentially pass that. This will be converted into like a reference, pass by reference thing. And so I don't think there'll be any copy here
Okay.
in the actual generated code. It's pretty easy for all of them to lead that stuff.
Okay.
Yeah.
Cool. Nice. Thanks. It helps me to understand. I just because I know with the function like interface, and then I just want to check for the loop.
Yeah.
Because we had that one in the benchmark for Eitzinger where there was a copy because of a const. We were taking a const that was actually just creating a copy on the stack.
Yeah.
Yeah.
Yeah. That's right. That was a little bit different though. Because there we were like
Yeah.
very explicitly telling the compiler to make a copy. Um,
Yeah. Okay, cool.
there's no way it could
I
not do that. It was doing what we told it to do.
okay. Okay. And here it's not like we're running into that risk where we accidentally might
Here
be
we don't
copying
require it to
stuff.
make a copy. Like we don't
Okay.
use the fact that it's a copy anywhere.
Yeah.
I
Cool.
don't think at least. And if there's always a chance we benchmark it and we find out I'm wrong, but if that happens, we can come back and fix it.
Yeah.
Um,
No, I'm with you. It just helps me to understand.
cool.
Yeah. Okay, so we're gonna
Right.
convert absolute index into a cursor, get the node, has it got space? If so, insert. Otherwise, we get
Yeah. So
into fragmentation land.
absolute index to a cursor, and we do that. We've got cursor to absolute. We got the other way here. Um,
That's what we need here, I think.
we need this is what it is. I think. That's the other way. That's cursor to absolute index. Takes the cursor, returns the absolute index. We want to take an
Oh, of
absolute index and
course.
give it a
Okay.
cursor, which I think
Okay.
happens in here. Um, yeah, well, here we got a start node too.
Oh, we actually have to iterate over our nodes now to convert it into an absolute
Yeah,
index.
that's
Yeah.
not great.
It's okay though because we've got our counts.
Got this, yeah.
Yeah,
We're at
exactly. Yeah,
absolute index of the first element. And so we do it.
yeah.
We also don't have that many nodes, right? How many nodes?
Yeah, that's the whole trick. We don't. These nodes are pretty big, so the iteration over the segmented array is actually really good. It's much better than a linked list. It's approaching that of an array. The larger we make our nodes, the more
Right,
like an
right.
array it becomes. And this optimization is even better because this is now all contiguous, the counts. So
So we have then like it's like cursor or absolute index to cursor function then?
yeah,
Or cursor from absolute index?
yeah,
Match that.
yeah. I'll just flip it around nicely. That's cool. P32.
There's gotta be like over 100, right? That's
Yeah,
89. Yeah, it's only 96. Cool.
yeah.
So then it's just gonna be array or for array dot what do we call it? It's well, I guess we want to iterate over nodes essentially and check against this.
Yeah, we just say I is
Um,
less than node count, the runtime node count, and then we want to go into that absolute indexes for first element and find one that is bigger than, and then we go back. So it is like that loop here that we've got elsewhere.
yeah, so it is kind of like this, yeah. So
Mm.
here we've got a start node. Instead, in this case, we just start from 0.
Yeah.
Okay, yeah, that works. So I can just copy this loop then, I guess. Um,
Yeah.
Same
And
thing
actually
about start
then,
node of 0.
yeah,
Just copies a little bit more context here. We can delete it if we don't need it.
because inserts always assume it's ascending order.
Yeah, that makes sense. Um, so it doesn't, that's not really, if we're finding just a single index, it doesn't really matter here.
Yeah.
Start node is 0. Needs to be at U32. Nice. I think this is a useless assert if we put that at 0, so I'm going to get rid of it. Oops. I node
Okay.
plus
What
1
were
is less than
we?
array.
Sorry, Isaac. What were we doing there? Greater than equal to.
This is asserting that this is essentially that we're just going to assert that 0 is greater than or equal to 0, or that anything is
Yeah.
greater than or
Yeah.
equal to 0. If we put
Okay.
0
Cool.
here, that seems kind of useless.
Yeah. No, I'm with you. Yeah. Thanks.
No problem. And so here, yep, this seems reasonable. Then,
So while there's a next node, check is the next node's absolute index before what we're looking for? Because if it is, that's where we want to start at least. Uh,
yep,
at the end, check that we haven't gone out of bounds. Uh,
yep. We need
okay,
just one little thing here. Do just yeah, array that first absolute index node makes sense.
yeah,
This right here.
I think what we should do is actually hoist that out so that we can assert on it like we do below. And the reason for that is because we need to be careful with how we use this. Like if we are mutating the table info stuff, then we need to be careful that we do update some of the metadata, like array counts we need to update. So having, you know how we calculate relative index here and then assert relative index is less than array counts for the node. That might be quite
Yeah.
useful. Yeah.
Hmm. Yeah, let's definitely take this. To do dead code. Interesting. I think we said this can never happen now.
Yeah.
So we can just come back to this later when we find the to do again.
Yeah. Yeah. Yeah.
I'm pretty sure we were confident this wouldn't break anything.
Yeah.
But we just need to get rid of it eventually.
Mm.
Um, I think I know what it was. We were refactoring this to like make more assumptions, and then this was like code we didn't want to delete yet because we weren't sure if we would want to change our mind again. I think we didn't
Yeah.
change our mind again, so we can probably just delete it.
Okay.
Um,
We don't use done there anyway. Yeah. Yeah.
yeah, so we can just make this an assert, just assert. We do use. Oh yeah, we don't even use done.
Yeah.
Well, the done was just to make this assert possible, I think. I think we can just
Okay.
assert it regardless of whether we're done or not. I think we're now saying that relative index will always be less than or equal to. Um, what? If we assert that this is the, the case, and then we check the opposite of this assert. You see this is how this assert in this lineup? Um,
Yeah, exactly. Yeah.
this is just dead. Let's delete it.
So
Like this
so done is always true here because it's the opposite of that
done
assert.
done is never true here.
Yeah. Good. That's a good proof. Symmetry
Cool.
at work again.
Same thing here. Done is
Yeah.
never true here either.
Yeah.
So we still want to grab this from up above.
And the reason it's never true, sorry, is because there's always at least one element, I think, at that point.
Yeah. Um, I've been messing with my keyboard layout again, so I've like made my broken my muscle memory for some things,
Yeah.
but it should be better long term. Um,
Yeah. Yeah, it will be. I wonder, like, if you
yeah,
if you
but
do
now
that, if you purposefully keep breaking your muscle memory, and then you retrain it, and then you break it, then you retrain it, it might be
yeah,
interesting to see the like how the body responds. Like, you might actually get some phenomenal improvement where you actually can just get to a whole new level because your your typing, you get so
interesting.
used to rewiring stuff. Like your brain will just become
And definitely,
like Einstein.
I think you definitely do get better at relearning stuff quicker. Um,
Yeah,
at least it's definitely been easier for me to make more adjustments as I've gone on with this stuff.
yeah,
My keyboard keeps getting weirder and weirder though, because now I've got like I've essentially got like on the home row, where my four fingers like rest on each side, like it'd be HJKL on the right hand, or not that, JKL semicolon
yeah,
on QWERTY layout.
yeah,
Um, and now I've got like those are now dual purpose keys, and so if you hold them down, you get like Control Shift Alt and like the GUI, like all the modifiers. So if you tap them, you get the letters still. If you hold them down, you get the modifiers. And so I no longer have to like
yeah.
reach around my keyboard for modifiers. I can just like use the home
Nice,
row. I've got the same thing on the other
nice.
hand too. And so like to
Okay.
type, yeah, so you can do still go do like you can still type everything, but now you've got like
Yeah.
these dual purpose keys that like they're pretty comfy.
Yeah.
I use
Yeah.
my pinkies a lot less, which was what the goal was. Just like use the
Oh,
pinkies
cool.
less, use the thumb. Um,
Okay, cool. Nice. I
yeah,
want to still like ask your help because I want to get the same keyboard as what you've got to I've got one of these like extended Apple keyboards, and
yeah,
the problem now is it's so long that when you put the trackpad next to it, it's like massively far
yeah,
for your hands to move. And this
yeah,
whole section of stuff I don't access. I only access here. So you're going from
yeah,
here to
yeah. I
here.
know what you mean.
All yeah.
So I've just got this for anybody watching. Which I don't even use some of these keys now. I don't use like this bottom left corner anymore on either side. Um, yeah,
Yeah.
and
Wow.
so only have the keys you use, and I put my mouse in the middle between the two halves, which is
Yeah.
kind of nice.
Hey,
Um,
awesome. Hey, Isaac.
yeah, I can definitely hit you
So
up with some links for that stuff.
yeah, have you checked out our chat? We've now got 155 viewers. I don't know what's
Oh,
happened.
whoa. Let's see
Hello,
how long it takes
everybody.
to chat. I don't have the chat numbers on my. Actually, I think I do. Yeah, WeChat shows me that I've joined the chat through IRC, and so
Yeah,
I can't see all your guys' names or whatever. But welcome
yeah.
everybody to the stream. Um,
I think you need to do another keyboard demo quickly. This is the perfect moment for that. Uh,
okay, yeah, we just got distracted and we're talking about keyboards, and so um, this is my keyboard. It's called a Corn, Corne. I started it together myself. It's only got like 42 keys, and I don't use four of them, so I only use 38 keys. But yeah,
yeah,
it's pretty nice. My fingers have to do a
yeah.
lot less reaching around to get to keys, and so it seems to be good for keeping my hands healthy when I sit in front of a computer all day. Um,
Yeah, yeah,
yep, let
that's
me get my
awesome. And
keyboards untangled.
yeah, we were chatting about like remapping keys on the corn, like if you're moving keys around, and
Yeah,
then what happens if you keep,
yeah,
you build up this muscle memory, then you remap everything, build up your muscle memory again. Maybe you just become like Einstein and get super fast hands or something. Yeah, yeah,
all the ragers can't chat because you have a have to follow for 10 minutes filter on in your Twitch chat.
yeah,
Um,
yeah. Yeah, so
I guess
let's
in
hang
10
around
minutes.
for like for 10 minutes. Yeah. Cool. So yeah, where we're at now is we've got a segmented array. It's a pretty cool data structure. It's in between an array and a linked list. So you can tune it and you can say what kind of insert performance do you want, what kind of lookup performance you want. And you can say, well, we want it to approach that of an array or that of a linked list. And it's really memory friendly. Um, and now what we're doing is implementing actual inserts into
Yeah.
this segmented array.
And another big reason we want this is because we want to do all our allocation up front, but we also want to dynamically distribute our resources between our different arrays in our larger project at runtime based on like what the runtime characteristics are of the data. And so the segmented array allows us to very easily use a pool allocator to allocate nodes, and then we can allocate a maximum number of nodes up front, and then have them get distributed between the different arrays at runtime very simply.
Yeah,
Um, and so that cuts down our overhead by a lot. You no longer have to
yeah,
allocate like the whole maximum amount for every single array.
yeah.
Um,
And then
yeah,
just even stepping out one layer further is all of this is a LSM tree storage engine, and it's different to the old LSM trees because the old ones were not in Zig, and you don't get as much safety, and they're not deterministic, so you can't use autonomous testing, which is the future of software testing. Like autonomous testing, you can simulate your software like in a wind tunnel, and if you find a bug, you can deterministically replay it again and again and again while you fix it. Whereas something like Jepsen for databases, Jepsen will find you bugs, but once it finds you the bug, maybe you can't rerun it and always get the same bug back. It's not deterministic. And also it runs in real time. So you have to actually run your cluster for hundreds of hours if you want to get the confidence. Whereas autonomous testing, you can speed up time. You literally tick time in a while loop. So you can simulate hundreds of hours of runtime with just a few seconds of real time. So basically, this is why we're building a new LSM storage engine, because we want it deterministic, so we can use these new testing methods. We want better memory efficiency. We want static allocation. So this segmented array structure is all about static allocation. And that's what Isaac was saying. That's why we've got a pool
And
that
also,
we can.
yeah. Yeah, and so allows us, this is part of a larger abstraction called the ManifestLevel, which is basically our in-memory store of metadata that allows us to then find where some key is located on disk and like which table it is on disk. And so we've already done the read path here, where we can now query the in-memory metadata laid out in our data structure. Now we're working on the write path to add data to this data structure. Yeah, so I think that's about where we are in a good high-level overview. So now you get to watch us figure out how to do insertion here. And so we've now just added this function, the cursor for absolute index, which will give us a segmented array cursor, which is just a node and a relative index then. And now we can take that into insert, I believe. So the first thing to do here is do const cursor equals x. Also, we have to be array dot. All right. And next up is, well, now we've got that. We now have the cursor, and so we need to check if the node is full. I think is the next thing to do, right?
Yeah. If it's got space, then we can just put it in and we're done.
Or if it's got space, we just put it in. Otherwise, we keep going, I guess. Yeah.
Yeah.
But if, well, I guess we have then here node elements equals array dot node elements cursor dot node. And so, do we insert after this cursor? Is that what we do, or do we insert? I guess we insert such that this element becomes this absolute index, and so we want to move the cursor to 1 to the right.
Exactly. Yeah, that's the insertion index for that element, just like you said.
Cool. And so yeah, we now have the current slice of elements at this node. And we need to have, what's the maximum slice of elements for a node? Do we have that here? Node capacity, perfect.
Yeah.
So if node elements dot length is less than node capacity, then we're just going to, well, we want to then we want to shift everything to the right by 1, starting with the relative index. We can also assert that the relative index is less than node elements, I guess. So there's an interesting case here where if our absolute index happens to be the first element of a node, instead of shifting everything in that node, we actually would be better to insert it to the previous node, right?
Yeah.
Then you don't have to shift anything.
Yeah, cool. That's really, really nice. We could do it in either node in that case. We could just decide.
We really could, yeah.
Because one node might be full. If it's full, then we go to the other one.
Yeah, that makes sense. And so we could say if let's do the common case first, and then we'll add some special cases like that later.
Yeah, that's what I was thinking too. These are all the fixer-uppers. And what I thought also is, instead of using node elements to take a slice and then check the length of that, we could also use the actual node count that we've got.
The node, it would be this.
Yeah, array counts we could use array counts for a node.
We want to get rid of array counts though. Remember, We want to, because this is useless data.
Okay. Okay.
Maybe
Yeah.
it's not useless. Well, I think we wanted to extract it more. I think we wanted to, because this can be derived from this array.
Yeah.
If I remember
So
correctly.
we
Could you like
probably do want to
contract this
get,
one with the next one or something?
yeah,
Um,
yeah. I think we do want to get rid of counts. So let's just do it the way we
cool. And so I was just going to do this pretty simply and say then, well, I guess we do need to modify counts here now, though. Should we try and get rid of counts right now and then come back to this? Or should we just go
Yeah,
roll with counts for now?
maybe we should see
I think
like
we should
if we
just
want
roll.
it. Yeah.
I think we
Do
should
you
just
want
roll with
to?
counts for now. Um,
Okay. Can we quickly just grab the code and see how many references do we have to it? So we've got it there.
uh, yeah, absolute index. We've got it quite a few instances. Yeah,
Okay.
absolute index. Cursor for absolute index. I mean, it's pretty nice to have. It could just be a function instead, then, though.
Yeah.
Um, should we just replace it with a function that just returns this? I guess that'd be kind of trivial. I think we should just use it with like as counts for now. It's pretty easy to replace with a function when we want to do that, if we want to do that. And
Yeah.
so it's definitely data we need to have available somehow. If it's and we don't really care if it's stored in an array or if it comes from a different array but was computed or whatever. And
Yeah.
so yeah,
And
let's
if we,
see.
just while we're on that subject, if we were to make a helper for it, then are we going to use our absolute indexes for node and then just do a little bit of iteration to calculate the node count?
Well, you just like subtract the current one from the previous one, I think. But then you need to add special cases for the start and the end. Um, but so like for a given node, the
Okay.
absolute index for that node minus the absolute index of the previous node or the next node, is it? I don't remember.
Next node.
Anyhow,
Yeah, the
that'll
next
give you the
node.
node count.
Okay, cool. Well,
Um,
then that's what we should do because that way we've got just less data to keep in sync. Calculating it is better,
indeed.
and we save memory across all the levels. Uh,
Yeah.
okay, but let's keep going, and then we maybe after this one we can then come and do that.
See, sounds good to me. I think it's easier to reason about this stuff right now without that. But
Yeah,
yeah. Anyhow, is that what it's called? Did I forget the name of it? It
just
just
counts.
counts. Okay.
Yeah.
Let me pass in node. Oops. So that's the node capacity. Then we're going to do, we're going to copy, I guess we do the mem copy first. Uh, T from will now be, it's like a copy forwards. We get overlapping ranges are fine for this as long as like the start pointer is before the destination pointer. We're only
Yeah,
shifting these like one element to the right, really, but I
yeah,
think still memnet copy is the way to go.
it's fine.
Um,
We would have to use copy backwards if we were going in the other direction. Yeah.
right, yeah. The destination is going to be, well, now we need to like go into the pointer, I guess. This is just nodes node, yeah. Um,
Oh, by the way, if it's your first time watching this and you want to know a little bit more what we're doing beyond what we've explained, Isaac and I actually did a really nice intro to all of this, and it's on YouTube on Tiger Beetle, and it's called Introducing Tiger Beetle's LSM Forest. So there's a whole lot more stuff in there. And we're also finding that if we watch it, we're learning stuff because we did this end of last year. So it was quite a fun intro session, just the big overview of everything. Yeah.
it looks like we've got Togglebit to thank for our viewers. So thank you, Togglebit. Seems like he's on his lunch break now.
Yeah.
Which we'll be doing soon
Awesome.
eventually, but I guess we'll keep going until he gets back, I guess.
Oh, we'll have to now. We're gonna just work hungry. Sorry about that 10-minute
Um,
delay. I'm a total Twitch newbie, so I think that was the default. And yeah,
that's very well the case. I don't have control over that. That's all Yaren's fault.
yeah, I'll claim that one. Blame the
All right,
producer.
so we've got our
Yeah.
pointer. We now need to slice it to the right. We need to here. Well, how much are we going to copy? So we want to copy. We can subtract the relative index of the cursor from. Well, it's just the relative index minus the count, I guess. So it's going to be const to copy is going to be array.counts node minus cursor.relative index. This is going to be the number of elements we need to shift to the right. So this is going to be pointer starting at the relative index. Index going, well, it's going to array.counts node. Actually, I think this is better than making a variable. Node. Well, we make you extract this into a counts variable, perhaps. That's slice one though. I'll get it all written out, then we can clean it up. Well, this is actually this is the +1, so it's the same thing but with a +1 where we want to copy from. Okay. Slowly we're getting there.
Yep.
Come on, Cocoon, give me the right thing. There we go. Come on. There we go. So I think this is the right thing now if we get rid of this +1. And this needs a +1 too, actually. Yeah.
So it's
Just split
kind of like
everything one to the right.
two copy is like the tail, and we're going from,
Yeah.
how much stuff is in the node,
I've actually
less
kind of
the,
gotten rid of this variable. We don't really need that anymore. I don't use
yeah,
it.
yeah,
Um,
yeah. Okay.
and then we say um, equals element, and then return.
Nice. That's a really cool way of doing it, like the +1, the +1. You can actually see the shift very clearly like that.
Yeah, it's very obvious it's just a shift. I think I might want to extract. I don't know. Maybe this is fine like this. It's a little bit verbose, um, but it's not horrible.
Yeah, no, no. I like that we don't have to introduce a variable into the scope and come up with a name. I
Yeah,
like the
I did do that
multi-line
for
copy.
pointer just to make it a little bit less
Yeah.
verbose because it's getting very verbose. But I think this
Uh,
is good like this.
It's also good because pointer is, it's nice to know that that's a pointer there because we want to,
Yeah.
that's how we're using these arrays. It's just arrays of pointers, and then we know like we need to go update our counts and stuff for that.
Yep. All right. And so this is now the case where we don't have to do any splitting. And so now we need to handle the complex case where we do have to split stuff, I guess.
Yeah.
Um, yeah. So let's add a comment there. There is enough space in the target node. We don't need to split nodes. There wasn't enough space. So split it. Or instead, there wasn't enough space. The target node was full. Um, full. So split it into two nodes. And so we just split
Yeah.
it on the halfway point, right?
Yeah.
Um,
We've got one bug so far.
oh yeah?
Yeah.
Hmm.
So in where we set the element, we just need to update the count, the node
Oh,
count.
of course, yes. And also the relative index of
Yeah.
every node after this one.
Yeah.
Um, yeah. So that's a little bit tricky actually. So the first thing we
Yeah.
need to do is do array counts node one and then we need to say for array dot what's this called again? Absolute index of first element.
Yeah.
Um, absolute index of first
Ruby
from
lives
this
on.
node onwards.
Yeah.
Sorry?
Ruby lives on in these names. Ruby will never die. It will always be in target middle source.
Yes. Also, did you see this? There was some thread about rewriting the Ruby's JIT optional thing in Rust, and the creator of Ruby, ended
That's
up saying that he prefers Zig to Rust in that thread, um, which I
yeah.
thought was pretty neat.
I thought that was so cool. You know, he's got yeah. I saw that was awesome.
As a longtime C programmer, I prefer Zig to Rust,
Yeah, yeah, yeah,
which I agree with.
yeah.
As a
It's
C
fine.
programmer.
Yeah.
Anyhow, so I
Hey,
think that's right though, isn't it? Node dot dot. Well, we also need to essentially cursor dot node.
yeah.
Cursor dot node,
And
and then
we've
we
actually
just
got the
take
same
this.
through this function. We've got every time we use node, we actually need to use cursor.node.
Um, I kind of want to just like add a. Maybe it'd be less verbose if we just kind of do that as a constant here. I don't know.
Yeah,
Um, we also do the same thing with relative index and make things a little bit less verbose here. Maybe
yeah.
do that for count instead of doing it for node. Let's try it like that first. If we do it for, I'll come back to that in a second. But here, if we just do it count equals array.counts node, this will now be quite a bit better, perhaps.
Yeah.
And there we go. Count. And then here we still need cursor.node, I guess, but that's not too bad. Um, it seems pretty
And
reasonable. I guess that
we
count really
just need
didn't help all that much, though.
it's yeah. We just need to do array counts and then pass cursor.node again. We've still got a few like line 9. Uh, if we go up to line 9 at the
Oh
end,
yeah,
like cursor.node, and also line 1 array.nodes node also can be cursor.node.
yeah.
I think that's the only two we've got.
Okay. I guess
Yeah,
it didn't help us all that much, but it
yeah,
did help us some. Like this is kind of verbose, and we got rid of these two at
yeah.
least, and this
What
one
what
too.
we what we could do is we could say instead of cursor we could just have C, and then you've got C node, C relative index.
Yeah, but then we don't you like one letter variable names in such a large scope though usually. Like
No,
they're
we
fine
only
in like a scope that's this small, but not in like this
exactly.
scope.
And I think the other idea for that is that like if we're doing a one letter variable name, we do it only for a primitive type, like a index, or if you're doing like matrix multiplication just with integers. But if it's a like a
Yeah,
compound
yeah.
type,
Where there's not
then
really
we,
any
then
more
we
information
write
about the thing.
yeah, yeah,
Yeah. All right. That you know what you agree that this is right though? We start at cursor.node and just iterate to the end of oh this is wrong. Wonderful. Um,
uh,
this needs to be restricted by node count array dot node count. There we go.
Cool. We'll have like a helper
Let's
for
probably
this.
just go on the next line now then. This is too long.
Yeah.
First element. Yep, so this just updates all of those things, and this is not really too hard to keep these in sync. We just always need to do both of these. When we do one, we gotta do the other as well. Eventually, we can kind of see
We're
how
just
that
gonna
gets cleaned up in the
do the
future.
loop. Yeah.
I'll get things working. We can clean it up for more in the future. I think this file is actually pretty easy for us to test like disjointly from our other. We don't have to do full testing, or we don't have to get everything compiling to test this bit of code, which is
No.
nice.
Yeah.
Can test for this.
Yeah,
and some
I was
fuzz
thinking the
tests.
same. Yeah,
And then also
definitely.
include in our larger simulation testing.
Yeah.
Yeah, so how do we split this in two nodes then?
Yeah, this is just, I agree with you. It's really nice. We can do some nice unit tests on this and fuzzing.
All right. So now we're going to kind of split this in half, I guess. So half equals count. Well, actually, it's node capacity over 2, because now we know that count is equal to node capacity. We can assert that, can't we? Assert. Since we have here only like a less than plus the assertion, we're now covered the whole space.
Yeah.
Because we know it can't be greater. So
that assertion is great to have. Shall we move it up one line so it's right next to the if, like we do elsewhere? This trick is such a cool trick, you know. Yeah, whenever you do a less than, and you expect that it couldn't possibly be greater than, then just to end it off like that and say, well, then it's got to be equal.
Oh yeah.
Yeah. There was some vulnerability recently where if they'd had this check, it wouldn't have happened. I can't remember which one it was.
I believe it.
It was off by one, just like this. But this pattern is so nice.
Yeah,
Like if,
it can be useful to like guard against underflow vulnerabilities too. If you end up doing an underflow and wrapping around, that's like often the only case where you can then get a greater than. Stuff like that.
Yeah, definitely. I've actually been thinking a lot about like buffer bleeds with underflow and checked arithmetic. Yeah, I don't know if you've seen me on Hacker News. I've been commenting a lot.
I haven't.
Yeah.
Your comments. There's good stuff there.
Yeah. I don't know, yeah, but it's basically what you're saying, you know, that it can wrap around, you get underflow, so that's nice.
Checked arithmetic is pretty powerful for catching those. Like there's a recent Linux kernel vulnerability or CVE. That's probably how you ended up commenting on these things in Hacker News.
I didn't. I was actually.
Kernel.
What was that one about?
That was an underflow leading to a buffer overrun. Which was there's this whole thing in the Linux kernel where they had like a bunch of. It basically allowed you to do privilege escalation if you already have the cap sysadmin thing. And so you might think that's not a big deal, right? And that's what most of the Linux code assumes. But since now we've got containers and containerization, you can have like capsys admin inside your container, and then you can basically break out Docker. So basically Docker we already know it's not secure, but now it's also got like, it's very clear that it's not secure.
Yeah.
And so basically you can just easily break out of Docker things, and that's been in the Linux kernel forever because it was essentially when all this code was written, it was kind of just assumed that if you already have root, then there's nothing more like we don't really have to audit this code all that carefully for security vulnerabilities because it's already assumed you have root, and so
it's funny like that
without having all the power.
Yeah, that gets to the heart of security because like security, everything must be exact. There must be no gaps, no semantic gaps. even if the principal would
Yeah.
say, well, we don't have to worry about it. But security is like if there's a slight gap, someone will exploit it because the meaning of
Yeah.
things
Or
changes.
yeah.
The semantic meaning
Exactly.
changes, and that ambiguity creates the gap. Uh, yeah,
Yeah.
but that's my conclusion. Like I even chatted with some red teamers in the Netherlands that are pretty good. And because I got in touch with them because they had this big slide at Black Hat where they said, ambiguity is like, and I took a screenshot. I said to the guy, like, thanks so much. This is exactly what it is, with
Cool.
the file format stuff I was doing. Yeah. Anyway, now, yeah, so we're
Yeah.
onto node
Yeah.
capacity
So
level two.
next up, we need to acquire a new node in the node pool. Um, and then we need to like shift all the nodes in this slice to the right. Like we need to shift all the pointers. So we need to do a mcopy on this array.
Yeah,
Same thing with the counts then, because we need to shift the counts to be in touch with the pointers.
yeah,
So basically we want to shift all these arrays one index to the right.
yeah,
Same with this one too.
yeah,
And then we're going to assign our new pointer to this. Um,
yeah,
and then set the count to half and update the counts for the old one as well.
yeah.
Okay.
So I think what we want
So
is we want actually another function here, insert node at an index, at an absolute index.
yeah, it's going to do the same kind of thing. It'll be the same mem copy with the plus ones and then the not plus ones.
Yeah,
Um, yeah, so this is not a pub function. This is just insert node. Um, I think we just call it insert node, and then an index is just one of the arguments.
yeah,
Um, then we're gonna have here we take in the index or we want to say like after. This would be a node index.
yeah.
Um,
I think we should do the same style. So we do absolute index. Here we call it node, and it's the node index
yeah.
where we want to insert a node,
Okay. And
just
then
like
we
we
need a
have for
node pool.
node elements.
Should we do the acquiring the node inside here too, like passing the node pool?
Yep.
Our imaginary interface,
Yeah.
which returns void. I think that's it, really. Um, it'll just say, I think we'll just have the, so yeah, it'll add a node at this index, shifting all the other nodes. And so after this function returns, the metadata for this node will be undefined. But the pointer will be there. Is that what we want to have? Is that the semantics we want? So then you'll have to manually fill in counts, and this after the insert returns. Maybe you just want a split node function. Um, I don't know. I think we should write it out and then factor out the stuff that's going to be shared between other things. Um,
Okay.
I think we should just leave this for now, and then because I'm not sure what goes in here, what doesn't go in here. The problem, and so I
Yeah.
think we should write it all in this outer function first, and then
I think
um,
everything goes in it. So if we insert a node, we're gonna go and shift everything.
do we
But it
pass
is more
in
like
then?
a split function. Yeah.
Yeah, yeah. If we could also just call it split node, and then we take in the node that we should split, and then it creates a new node. I think that's better. Let's try that.
Yeah.
And then it does. Well, we don't need that comment, but we do need this half variable. Um, and then we'll need to acquire a new node. Well, I guess we can acquire that later, because acquiring it can't fail. It'll panic if it fails. And so
Yeah.
we're free to we don't need to have like any early returns. We can do that later. And just here, we'll just start right away with these copy things. So mem.copy. We're copying now node pointers, I guess. So they're copying this type here. Yeah. And we're copying them, I guess, from array nodes. The current node is well, we're copying them to node +1. I guess we have the +1s first. So actually, get right without the +1s, and I can add them later. Sorry, I'm just thinking about myself in my head right now.
No problem. I think we should ban sorry on stream. It just can't be said on stream. No sorry.
I agree. Node count. Unapologetically talking to myself.
The only time we can apologize is if we've set a 10-minute default on chat.
All right, so there we've got our +1s here, and is that right? Read on node count. So we copy all the nodes from the node we're splitting to read.node count. So actually, I think we might want to do the next node.
Yeah. You see
because
that this
we
is. Sorry, Isaac. Over to you.
So the node's got like two halves, right? And so we want to avoid moving the lower half of the data. We want to keep that where it is and just copy the upper half of the data to the new node. So that means the new node's got to come after the node we were splitting. Does that make sense?
Yep. And also, I think here we want to split node needs to know the index into the node at which to split, doesn't it? Or not?
Well, I thought we were always going to split them in half, though, right? Or do you want to like do the insertion at the same time as we split them? Are we going to split at the place where we're trying to insert to, or always the halfway point? I think we always want to split the halfway point, right? Otherwise, you get very strange behavior in edge cases where you end up splitting a node like at the first index, and then you always want to split the halfway point for sure.
Yeah.
Then
okay.
So I think one way to do this is to just say, if this path fails and we split the node, then we just like run this code again. That'd be the very simple way to do this. Because then it was guaranteed to take this path, because we know that we then have made the node where this would be inserted to. And the absolute index stays the same. Splitting a node doesn't change like the absolute index of anything, because it's just taking
Maybe what we should do is in split node right at the top, just assert again that the node is full, because we don't expect split node to be called if it isn't.
What's gonna be array counts node.
Nice.
Cool.
Yep.
And
Isaac, maybe what we could do while we're at it is we can just, okay, maybe this is overkill and we want to first sketch out the design. So don't worry about it, but we could check that node is within bounds.
Oh yeah, we could. Yeah, why not? Just copy this one.
Yeah.
And so I guess we don't even need the half yet, really. That can come down later. First, we're just going to copy it to make space in our pointer, or in our parallel arrays. The new node. I think that's the way to go. So now the same thing essentially for the, well, I want to, I know what I'm doing. Sorry, I'm still messing around with my key bindings because I've changed too many things. But I'm getting better at it slowly, and long term it'll be awesome. Um,
yeah,
also type FW instead of 32 too often. Anyhow, we've now got U32s. No, we don't want to copy not from nodes, but we want to copy the counts and the absolute indexes. Those are the other two things we
yeah,
need to copy. The node count needs to be increased by 1 as well. Let's not forget
yep,
that.
yeah.
Just before I forget it. Now here we need to want to copy counts. Or just count, I think. It's counts.
It's counts, yeah.
Yeah, ZLS just told me.
Nice.
And then same
Thanks.
thing for the really long one. That one. That's 88 columns, not bad.
Okay.
So those are our shifting of the data. Node
And
count
it's
plus equals 1.
critical that we only increment node count at the end, otherwise all our copies are wrong.
Indeed, yes. And now we're going to also then assign the new pointer to what we get from node pool. So array.nodes node equals node pool dot get node to do implement node pool.
Nice.
Okay,
Yeah.
now we need to copy the actual node data, I guess. We need to fill in now these two things, counts and absolute index of first element, and we need to copy the half of the node data to the new node.
Okay.
Or, we just actually I just got this backwards though, because I think we actually want to, we want to keep this node in place, but then add the new one after this node. Does that make sense? Because we want to keep the first half of the node in place, essentially.
Yeah.
And
Yeah.
so what we should do here is, instead of using node in these copies, we should add like new node. New node equals node plus
Or
1.
or we could call it tail. Tail
Tail?
is everything. Tail is everything after the node.
Or like, so like say tail, well, tail will be this to, I'm not totally convinced by that name in this context.
Okay.
Tail would be nice if it was like if it was a slice, but here it's like an index we're starting our
Yeah.
slice at.
Yeah. Yeah. Okay. New node is nice.
Um, New node. All right, that's still short enough. Cool. And then we now assign the pointer to new node as well, which is very important. We're not like overwriting the old node.
Mm.
It's what we were doing before I just did this. Um,
Yeah.
all right.
Yeah.
So yeah, let's see. Insert the new node after the current after node. Node we are split or being split. Yep. And now we need to. Now we've got the new node. We just need to set the new node's count and index of first element and copy the second half of the elements from node to new node. And, we don't actually have to update these things for nodes that have been copied. We only need to update this and this for the two nodes for the nodes that is being split and the new node. The other ones are still fine because the absolute indexes aren't affected by this splitting. You follow that? Because like we're just taking like the absolute index of the current node and splitting that between the current node and the new node. And so it has the same total as the current absolute index. So that won't actually affect the
Okay.
following nodes in this array.
Okay. But we do have to shift array counts along, right?
We have to shift both of them, yes. Both of them
Yeah,
need to
yeah.
be shifted, but they don't need to be like updated. Like here we do the updating of all the following absolute indexes. Here
Okay.
we don't need to do that here. We just update the or we just need to reassign the two ones for the current node and
Yeah.
the new node.
Okay.
And so let's do the copy for the node data now, I guess. Copy is from new node pointer to old node pointer. Um, yeah, so let's get the node pointer data, I think. Const pointer. Oops. Equals array dot nodes node. New pointer. And then we're going to copy from the halfway point. Well, actually, we want like node elements, actually. We don't really care about the pointers. So it does need to be bounded by the count as well. So I think we can just
Yeah.
use node elements here, actually. Um,
Okay.
but we want your new pointer, we do want. And so this will be copying to new pointer. Um, just Yeah, we don't need to have any end bound on this actually, because we just want to copy all of them. If we could do this like 0, half, just to make sure as a safety check.
Yeah.
Um, well, then we need to actually make sure this is like divided in. We need to deal with the rounding here if it's not
Yeah.
an even number, to make sure we don't lose a table info. Um,
Yeah. I was also wondering, Isaac, it's a little bit of a sidetrack, but just in general, like how we shift the new nodes across. Over there, we're using new node quite a lot as our index, which is cool. So we're saying new node, new node, new node. But there, if we accidentally use node, then like it would be wrong. But it seems like we're using new node in in like this block of code. So it's kind of like we could almost extract, like later on, we could extract that out and just pass in the actual node, so that it's separate, so that we're in the same like function, we're not using new node and node. We're only ever using one
yeah,
index. That that way it doesn't matter if we
I think
swap
this
them.
can definitely get cleaned up,
Uh,
but I'm not sure
yeah,
what that should look like yet.
yeah. And I'm also coming around. Like I think how you said earlier, let's not abstract it yet. Let's just put everything in. We could almost move
Yeah,
this right up into the previous function for now instead of calling it split mode. Uh,
yeah, I think keeping it separate is actually not bad. I'm not sure if
yeah,
it's good yet or not, but I
we
kind
should
of like that
wait
this function doesn't
until we.
actually affect the array. All it does is split the node. It doesn't affect the data that's stored in the array actually. It just
Yeah,
affects how it's stored, like the memory layout.
yeah, yeah.
Um, and so after this
Okay.
function runs, there's actually no change in any of the data stored. It's just stored differently across more
Yeah,
nodes. And, and so it does like it's the opposite of compaction.
yeah,
Um,
yeah, yeah. Cool. Does that idea make sense
um,
though for later, that we can, wherever we're using new node, we can actually try and put that into a separate scope so that we don't accidentally
yeah,
use node.
I think you've got a good point there. Yeah, I think we just need to finish up the logic
Yeah,
first and then see what makes sense.
yeah.
Um, I'm we're not getting this right now. We also need to make this a slice from. Oh no, it's not from that. It's from half onwards, isn't it? Yeah. this now slices us from half to count, or to the end of node elements, which is bounded by the node count.
Yeah.
And then we copy that into new pointer from 0 dot dot half, but this is now the wrong bound. This is actually going to be half plus 1 if node capacity was odd. And so the simplest way to fix this bug, because right now we're just getting a safety panic there if node capacity happens to be odd.
Yeah.
Maybe it's never odd. Maybe we're fine with that.
We can do a
We just call it
comp
quantum assert. We can just quantum assert this is equal to 0, and then keep our safety thing here. So comp, I love Zig. It's pretty clear why we're asserting that right here.
Yeah, I think
Otherwise,
like
we'd have
later
to
on,
get rid of
when we're done, we should just add a comment and say to make it crystal clear.
Yeah. Or we could just say we can do well. This is not really necessary either. We should probably, yeah, this is really just a redundant bounds check, but it's still nice to have.
Yeah. We should try in the comment to say what would happen if it wasn't even, if it's odd.
Odd. This. Fail. That's not very helpful comment. It makes it clear this bounce check is redundant though, because it's not really necessary. It's not a bug to not to delete it.
Yeah.
But it's just another assertion, as we like those.
Yeah. It also just shows what we're thinking. It's a more like the assertion is now operating at a higher level of meaning.
You see that you're copying like from half, the second half, from half onwards to the first half, 0 to half. And so it's very clear.
Can we slice the pointer like that? Because array nodes, we actually just have a pointer. The length, there isn't a length in there. We're storing.
Oh, actually, it's an array pointer. Oh, that's even better. So we get bounce checking at the end too, but yeah, it's actually slicing a pointer to an array, which is totally fine.
Oh, okay, cool. Okay.
It'd also be fine if it was instead, like just instead of a pointer to array, it's just like a many pointer. That'll also be fine.
Okay, that's what I thought we had. Yeah.
You couldn't slice that though. That wouldn't be sliceable. It's only pointing to one item.
Exactly. Yeah.
Yeah.
Cool.
There we go.
But if we had a pointer to many, then we wouldn't get bounds checking on the slice.
Exactly. Yeah. And so here we do get bounds check that half is less than node capacity essentially.
Yeah.
If it was just a many pointer, we wouldn't get that. If we didn't have this, we wouldn't get bounds checking on the copy from this into this. Now we're asserting that that this slice is greater than or equal to this slice in length.
Okay.
That's what this bounds check does.
Yeah.
I still think we should have a copy exact function, but we haven't managed to do that yet.
Yeah, I agree. Copy exact. And I was wanting to ask you, our div seal helper that we keep wanting to re-implement, is there a way that we could put that in math.zig? I was wondering.
I think we can make a good case for it because it's like API we actually want to use.
Yeah. So are we thinking that in divseal and mathzig, we have a comp time function to determine the return type so that if we know there can't be an error, we change the signature? Is that what we're thinking, or how are you thinking to do it?
Um, yeah, I'm not sure what the right solution is there. I think that could work though. Yeah, we could play with that. Gets a little bit tricky though. I think that works out because you can't use an inferred error set, but another error set is just part of the type system, and so you just have a comp time function that returns the return type based on the type of the
Exactly.
parameters. Yeah,
Yeah.
that we can definitely do that.
And then, or actually, we could just add and say div seal assert. So instead of returning an error, it just asserts that the denominator isn't zero, and then you can't have any other errors because it's all integers and it's unsigned.
Yeah,
Uh,
okay, that makes sense. That's also good to have 'cause that's also part of what we were doing is just doing the assertion instead of
yeah,
um, yeah. But is it even necessary if you've got unsigned? I guess still you have the division by zero thing, but
yeah,
you don't have like the yeah. We should definitely try and upstream that.
yeah.
Um,
Yeah, at present, like in the standard lib, it returns an error, I think, if the denominator is zero. That's the only case we need to
right.
handle for unsigned.
Yeah, whereas we want the assertion version. Um,
Mm,
yeah.
yeah, cool.
Yeah, I don't think you can really justify a built-in for that though. It is very easy to implement in userland, and there's no hardware
Yeah.
instruction that is div seal.
Yeah, it does feel like it could be a div seal because you've got div floor, div exact, uh,
Yeah, like just
but
one that
it
does the
isn't.
assert. And then like all the other stuff in math, like the reason we return errors there is to like allow you to handle the error instead of getting the
Yeah,
assertion failure. So they all
yeah,
otherwise correspond to either like a built-in function or syntax or whatnot.
yeah.
Um,
So that kind of does make a case
yeah,
for a built-in. Although, like again, I'm with you that the built-in, like div seal, isn't a steep. We're not lowering to some instruction there for that.
yeah,
Uh,
yeah. We'll see. Um, we do also have like
cool.
maximum and minimum built-ins now.
Yeah,
I don't know if you saw that, but actually
I
wasn't in the
saw.
release. Or maybe it
Yeah,
was.
it it's in the docs because I was reading up on them for the vector stuff because for the set
Yeah,
associative cache that we're doing. So they're pretty cool.
yeah,
I think they make sense as built-ins because they can work with vectors and vectors lower
exactly.
to
They also work for
SIMD
scalars just
intrinsics.
fine, and so
Yeah,
people have stopped
yeah,
using like the SD that or whatever we had before. I think it was math.min and math.max. People just kind of like
yeah,
stopped using those and started using the built-ins instead,
yeah,
um,
yeah,
which is neat.
yeah.
Anyhow, um, where are we at? We've now got our data copied to the new pointer. Now we need to update the absolute indexes and counts. So array dot well, let's just first subtract it from node elements. Or subtract half from the count of node elements. Array dot counts node minus equals half. Array dot well, absolute index of first element for node isn't affected. Interesting.
Yeah,
That's changed. That
yeah,
stays the same. And then we can say array dot oops dot new accounts new node. This is going to be set equal to node capacity minus half. Actually, it could just also be equal to half. But well, this code is now written to handle the odd. If this happened to be if this assert failed, these two lines would still be right the way I just wrote them.
okay, cool.
Um, I'm not sure if we need that complexity though, because we can also just say that both of these are equal to half, and that'd be also fine because we have this assert.
Yeah,
Um,
I think the other way is nicer because it's just correct. It's a
Yeah, it's just
lower
always
lower
correct.
lower lower
Yeah,
bar for correctness.
cool. And then we need to do array dot absolute index for first element, new node. It's going to be equal to the previous one. Don't we have like a helper for this or something? First absolute index. Look at that. You can just use
Hey,
that instead of typing out the full thing.
uh,
Um,
can we rely on that here? Because maybe we need to still do bookkeeping for that to be accurate.
I can also just like do without it here if you like. It is simpler, I guess.
Yeah,
Um,
I think it's better
um,
if we don't rely
node
on helper
plus.
functions in here.
Um, I'm gonna use array.counts now because we just updated it, and so I think it's kind
Yeah,
of nice like that. And wrap this, I guess.
yeah.
How's that? This variable name, this field name is very long. Um, so now we've just got absolute index of first element plus array.counts node. So that's right. Um, yep. So are we done now? Have we forgotten to update anything? We got node count there.
So are we saying that the absolute index of the tail nodes, all we're doing is we're changing the underlying physical um, like storage area for the data, but we're not
Yep.
changing the logical indexes on top. We're just moving data around
Right.
in the nodes at the bottom. Uh,
Exactly. And so the absolute index of the first element is only affected for the two nodes we touch. We don't actually change this for the following nodes.
okay,
Um,
that makes sense. Yeah. And then from then we get a new node from our node pool, and we put it into nodes at new node. I Is it not actually that we put it in at node, or is it at
no,
new
we
node?
don't, because we want to not move. We want to move as copy as little data as possible here, and so we copy the second half to the new node, which means the new node has to come after the node, and so we
Okay.
leave node in place and copy the second half of its data to the next node, which is our new node. Um,
What would be the alternative? Like with how would our copy work if we
um,
um,
we would then, if we wanted to insert the new node at the index, at this node index, we would then need to copy the first half of data from the current node to the new node, and then shift the second half of the data to the start of the old node. You'd have to do two
of
copies
course,
instead
yeah.
of one.
Okay, cool. So what split node does is you pass in a node index, and it's going to insert a node after that node, but it and then
Yep.
it's going to move the latter half of the data in node into new node.
Yep.
Yeah. Okay.
It
Great.
won't affect the absolute indexes of anything.
No,
Um, yeah.
just some of the physical indexes for the two nodes only.
Yeah.
Yeah.
So we should document this, I guess.
Yeah. Yeah.
Split the given node into two nodes, inserting the new node directly after the given node, or after this node.
Yeah.
Do you like the given thing, or just split node into two nodes?
Yeah.
Um,
Um, we could say split the node at index node into two nodes, inserting the new node directly after node. And we could put where we say add index node, we could put that in with backticks to show that that's the.
Nice. Cool.
And we could use the backticks again over there if you like. I don't know.
Did I put the period inside the backticks or not? I think not. I don't know.
Just
It's always kind of weird.
Put it outside. Yeah.
Yeah.
Because
it looks so weird. I think in non-monospaced text, it looks like kind of better to put it inside. But in monospaced fonts, it looks so much. It looks so weird.
Yeah. And backticks are also taking the literal meaning. So if we put the full stop in there, then it would be wrong.
Yeah. Exactly. But like rotation marks, even still, like it looks kind of. If there are rotation marks, it also looks funny in monospaced text, I feel like. Anyhow, this validates all cursors. Array or segmented arrays, but does not affect absolute index.
Yeah.
How's that?
Yep, that's cool. I'm going to just switch off our AC quick.
Cool. I think we've got that all pretty well figured out now.
Yeah.
Cool. Got 3 copies here. This is all like pretty reasonable code too. It's not too crazy. And so now to solve this, we can now just call this function and then do
the other
same
idea
thing we do here.
Yeah. Sorry, Isaac. Another idea I had is we could do, instead of calling it node and new node, we can call it A and B. So A is node and B is the one after that, which is new node. That way we don't maybe.
Just call this one A or what?
Yeah. I don't know. Maybe ultimately we want to take as much of the new node stuff out so that we can't mix it up and get it wrong. That's my only worry. But we can test.
I feel like new node and node is easier to remember which is which than A and B. I don't know.
Okay. Yeah. Okay.
Cool. Actually, I'm not too unhappy with how this works right now. I mean, you can always just make it one variable typo and have a CVE just from logic bugs.
Yeah.
No matter what language you write in.
We've got so many uses of node here that it's hard, like for my eyes, it's hard to see, are we using new node or should we be using node?
Okay.
That's more the thing. So that's why I thought if we can extract as much of the new node stuff out, then it's only ever going to have node as its argument, and we can't get it wrong. Because then we'll just call that function with node plus 1.
Should we have a function that says then like shift to right? Shift right by 1 that then does these 3 things?
Yeah, that's it.
Okay, let's try that. This is a bad function name for now. I think it is.
Yeah.
And then we need to pass in node. Well, and it's just going to take, yeah. We want to call we also just call like n to make it like less easy to confuse with a node in this function because it's not going to be node here.
Yeah.
It's going to be new node we pass in here.
Yeah.
And maybe this function's short enough we don't need the longer variable name.
Yeah. We do. I think node is good because this is now just another function. Like we've got elements for node and that takes node. Uh,
All right. We could also make this more concise, perhaps, by doing like const. I don't know. I wanted to like use like one other variable names, like just use like a equals node, and then say const b equals array.node count. This may not work very well, but you can then just do like on one line a plus one, or b plus one, and then these are just a and b.
yeah.
Is that more readable?
Yep. That's nice.
That one's definitely a lot shorter.
Yeah.
And this one, I think, probably gets a bit more readable too, even though it's like, yeah, stuff's a little bit awkward to select sometimes.
Cool.
Is that better or not? I'm not sure I like it.
Yeah. I would say maybe we could use C because it's more of a count, not an index. Index, like we're kind of making it seem like if you have a sort function, A and B, they would have the same kind, they would be the same type. But index and a count actually are different because you
Well,
have to
they
convert a
are
count to an
start and end.
index.
This is
Yeah,
actually this
yeah,
is also an index though. We're using it as an index at least.
yeah, yeah, yeah,
Um,
yeah. No, but it's cool. A and B is fine. I guess the maybe what you're thinking is absolute index of first element. Now we can't get that on one line.
yeah, no, we can't really. I think maybe how it was before was better.
Yeah,
Um, just leave it with node and node count directly, and just not have
yeah,
any variables here. Just do 3 copies, and that's all it is.
yeah.
Yeah. What about the
Nice.
name? Shift right by one. Horrible.
No, let's do that so long. We could
What
call
shift
it
what right by one?
shift nodes right by one.
Yeah. Uh, shift nodes right. Do we need the by one?
No, that's fine then.
Or just shift nodes even? I don't know. If you need the right.
Uh, I think right is nice. Then you see the direction.
Okay. That does make this function a lot bit less scary too.
Yeah.
Um, just yeah. Cool. Um,
Okay,
actually,
it's
it's
it's kind of
after. Hmm.
what we do with that function now is we're cleaning up our control flow. So kind of what we did when we did the compaction iterators, remember, and we had our big control flow was quite a big block, and we abstracted that
Yeah.
out so that we could make the control flow really clear.
Yeah, that makes sense. Still feels weird to like pass in this line doesn't really read nicely to me. Shift nodes right, new node. Um,
Okay.
I feel like I want to pass node plus one here and then define new node first of all, like when you get to here. Like do
Yeah.
this. Does that seem better to you?
Yeah, or what we could do is change the function name. So we say, okay, here's a node. Everything after this shift to the right.
It actually does shift in the node you pass. Um, it's shifting
Yeah,
node and every node after it to
yeah,
node plus one and every node after that. And
yeah,
so
yeah.
This is the same value as new node, but it has a different meaning after this function is ended. And so that's why I decided to do the name, calling it new node. We do it first after the function's ended, because before this function runs, node plus one is the node directly after this node. After this
Yeah.
function runs, it's now an empty slot where we can then call new node and put our new data in there. Does that
Yeah.
make sense?
Yeah, that's cool.
So I think just calling it passing node plus one here is the right call.
Yeah.
That was also bugging me before with the new node stuff where we had in here. I think that was probably bugging you too, because we were then like shifting new node to the right by one, even though it wasn't actually new node yet.
Yeah. 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 I
Cool.
didn't get that. That bugs me now, like that you said. But I didn't pick it up yet. Uh, I
Cool.
kept worrying that we're getting our usages of the two correct across because we've got quite a
Yeah,
long
yeah.
function. Yeah.
And it was, it wasn't like really semantically correct what the name was, and so that was
Yeah.
definitely like a valid concern. Um,
Yeah. Yeah. So we could call it shift nodes right from, and then node plus one,
uh,
if you like, if that helps the name.
yeah,
Otherwise, it's
sure.
fine. Shift nodes right from.
Yeah, because it's node plus one in all following nodes.
Mm.
It just says shift the shift data for node all one. This may be used. That's good.
Yeah. And I was just wondering, Isaac, we maybe we want to see how much of the metadata, where we update and correct stuff. Maybe we can put a little bit into shift nodes right, because shift nodes right, do we want that also to increment node count or not? We only want to do that when we
I
actually
think
put a
node
node
count.
in.
Yeah, you're right. Node
Yeah,
count should be
yeah.
implemented be done in there. But the other rest I think shouldn't.
Mm.
This leaves. Um, Whoops.
Maybe you like
Um,
what this function is that it's inserting a blank node and shifting stuff to the
yeah.
right.
Yeah, yeah, that's good. So insert empty node. Um,
Yeah.
yeah, that's better. Um, or make space. It's not really inserting a
Uh,
node yet though because it doesn't assign the pointer. Though it could do that too. It could also
I
do
think it
it could also
should.
do this. Yeah,
It
cool.
should.
Yeah,
And
insert.
so what it'll first do is it'll shift stuff to the right using the actual node index. And then after that, it'll increment the node count. And then it'll put
Yeah,
in the empty node. I think it's a great name. Yeah.
yeah. An index node. Then we need to grab this, and this is actually going to be node.
Yeah.
Um, and that makes sense now in this context. Cool. Um, we know we need to pass in the node pool too. Node pool. No. Oops. Node. Now just array dot insert empty node. Node Cool. Node +1, and then
Oh, now we actually don't want to do the +1 anymore. We want to just pass in the node where we want the empty node at, and then internally in
which is new. Um,
new node. Okay.
we do want the +1 still,
Yeah.
because we want the new node to be after then we want the new node to be right after this node, and so node +1 is the place we want the empty node to be.
Okay. But now, okay, then we must pass new node into the head.
Indeed, I
Yeah.
just messed that up, didn't
Yeah.
I?
Cool.
Cool.
And is there any other bookkeeping that we can do in insert empty node? Anything that we can move
No,
into it?
because we can't do these things until we have like done half. And if we like make this thing aware of like the half split thing, then then we just move everything in there, essentially.
Yeah. Okay.
Empty
What
node. We
what we
could
could have it
do.
do? So you go for it.
I was going to set these two things to undefined for the new
Yeah.
node.
Yeah.
This is a safety thing.
Yep.
Node or dot counts node. Actually, it counts. It would be 0. It would be the normal thing. It's inserts an empty node, right? And so, well, but we never have empty nodes. And empty node isn't valid, so I'm going to put these to undefined.
Yeah.
And just make sure, just to ensure that they get filled in and don't get reused. Because if we don't do
Yeah.
this, then this will be like a no-op in like optimized builds, you know.
Yeah.
It'll just write OXAA and debug builds.
Yeah.
You can even do this only if you have safety on, but it's not
Yeah.
expensive, and so
No, it
these are just
isn't.
U32s.
Yeah.
It just ensures
Wait,
that we don't accidentally reuse the valid previous things that were here.
yeah, that's a great idea. For absolute index of first element, we must just index into that. We must pass node
Oh
node
yes.
there as an index. And uh, we can maybe over here we can drop the to do implement node pool because we'll get a compile error. Like,
All right. Yeah.
or
We
what do you
will.
think?
That's
And then I
fine. Yeah.
think I actually think the how you had it grouped is nice, but we should just move the whole metadata group one down after the copies. And then, so we do node count, put in the node counts. We don't have to change the counts of subsequent elements that are shifted.
Yeah.
Okay, great. And then I was wondering, maybe we can actually return the pointer as the result because we already, the way we use this upstairs is, or maybe that's overkill.
Hmm. I think that seems kind of a little bit weird to me because you already have access to it. Like you don't need to return it if you can already get it from right here.
Yeah.
Um,
It just might help to
and so
bind the two together because we,
yeah. Then it seems like you should like assign the pointer here though. If you're returning the pointer, I'd expect you like have to need to assign it here. Like then to set the pointer slot to undefined here. You also do that and just like set this to undefined and then do the pointer part here.
yeah, I'm happy with that. Yeah,
I don't know.
cool.
I mean, just leaving it like
Void,
this is fine.
yeah. Oh, were you thinking that we pass in the new node and we pass in the new pointer instead of insert empty node doing the
Oh
allocation?
no. I was thinking if it returned a pointer, we would then expect us to need to assign the pointer to array.nodes here, just like we have to assign the counts in the absolute index.
Yeah,
But that doesn't really make sense, I feel
no.
like.
Oh, of
Um,
course. Okay. Yeah.
Yeah, I think it should just deal with the pointer.
Yeah.
But maybe it should just not take the node pool and just insert an empty, deal with the node pool here and split. But then there isn't really a full node. I think it's good like this. I think this is the
Yeah.
right.
Cool. I agree. I'm happy that we do as much bookkeeping as soon as possible when we can.
Yeah. Node count is definitely belongs in here. I think pointer does too. And this is just, yeah, safety, I guess, and being explicit about
Mm,
what our intent is. It's also just
mm.
like kind of documentation. When we come
Yeah.
back and look at this code, it's like we definitely meant for this to be undefined
Yeah. Yeah.
here.
Yeah. Exactly. It's really nice. Okay.
Yep, we got our split node now.
Yeah. Can
And
I
now,
just to catch up again? It's so we insert a new node after the node, then we take the current node, divide it by two, then we copy the node elements, and node elements itself is going to return a slice of the actual elements according to the count of that node. And
oh,
we haven't messed with that node's count,
actually,
but
we
we
know this
have.
node count has to be capacity. Um, so we can actually simplify
Hmm.
that. We don't need to use node elements here. That can just
Yeah,
be just the pointer of node.
yeah,
I don't know what I was thinking there. We could do here pointer and new pointer.
yeah.
And then get rid of this node elements call. Wow, that was messy. There we go.
Cool. So it's only counts and absolute index for new node that are undefined.
We also need to update the one of the previous node because have taken away half of its elements now.
Yeah.
Um, Actually, this is
Okay.
wrong, isn't it? Um, yeah. Well, this is right. It should be no. This is actually wrong. If it's not if the, it's right correct it's correct right now. But if this assert wasn't here, this would be wrong. We need to
Yeah.
do this needs to be equals half because we've now taken away up to up to half is still there. Then from half
Yeah.
onwards is gone.
Okay.
Um, this is correct though,
Yeah.
even if this is odd.
Yeah.
Cool.
Node capacity minus half. Uh, yeah. And then
Yeah.
we have to set the index for the new node, which will be after the node. So it'll be that node plus the array counts node, which is not correct. So the order of
Yep.
these matters. Yeah.
It does, but I think
Yeah.
it's nicer to write it like this though. So then
Yeah.
we only have to get this right once
Yeah.
here, and then we can just use it here. Yeah.
Okay. We could even just not use it and just say it's node plus half. That would be safer because then we can
Yeah.
swap these lines
We
around.
well, I said it is safer. I feel like this is more readable though.
Hmm. Uh,
But I
I
guess
think
half
half is
I'm fine
fine.
with
Yeah.
half isn't really bad. Just do
Yeah.
that. It's weird how this lines up.
Yeah.
like the indentation is the same as the new underscore. It's 4 characters.
Yeah, yeah, cool.
That's split node.
And yeah, and just to ask for pointer and new pointer, so they line up. Do you want to do A and B there?
Um,
Not really.
I don't want to. I want to keep it like corresponding with node and new node.
Yeah,
Um, I think it's just cleaner like that, and it's not too
yeah,
verbose in any way. I think lining
yeah,
them up isn't really worth it.
yeah. Okay. Yeah, great.
Cool.
What do you think? I guess it's
Okay,
time we need some fuel. Uh,
we do. I'm getting kind of hungry.
yeah,
Um,
yeah,
when do you want to come back?
yeah. Yeah. Shall we do like how do you feel? Like is a 30-minute good for you?
Um, like 35 maybe?
Okay. Well, let's do 45. Then we're back on 1/2 past. Uh,
Okay, that's easy
yeah,
then. Cool.
yeah, yeah.
See you
Cheers,
then.
everybody. We'll see you just now. Yeah, cool. Hey everybody, we're back.
Whoa, you're really loud. Um, just a second. Wait, that could be on my end actually. I was listening to music.
Okay,
Um,
cool. Let me.
cool.
Is
Better
it?
now? I think
Yeah.
I think that's normal on my end. If everything seems normal to you, I think we're good.
Okay. It looks
Um,
like my input is fine. I'm just getting a bit of
cool.
feedback.
That's probably just my
Okay.
end. All right. I think you're back quiet again, so you shouldn't get any more feedback, hopefully. All
Okay.
right.
Cool.
So we've now got our split node function done, we think, and we're back on to insert element.
Nice.
So I think one way we could do this is yeah, we can here just check if the node's full. If it's not full, if it's full, we can just split it right away and then get a new cursor and then do the same path for both cases.
Yeah,
Does that sound good?
that's great. Awesome idea. I'm getting a tiny little bit
Yeah,
of feedback, just ever so slight. It's almost gone.
ever so slight. All right.
Uh,
Should make you even another tad quieter, and then that should be fine.
awesome. Thanks,
I feel like
guys.
Discord's automatic like noise or feedback cancellation is a lot worse than Google's. Um, like I've never noticed feedback with my mic set up on like Google Meet or Zoom or whatever, but Discord I often get feedback.
Yeah. Yeah.
Um,
Yeah, they probably don't have, well, or who knows, what they've got
yeah,
in their filtering.
I mean it's a complex problem for sure.
Yeah,
All right, so and it can also be solved by my mic just like being farther away from my speakers probably, but
yeah,
yeah, or if I use headphones.
yeah,
Anyhow, so now we've got this node is less than node capacity check. We want to kind of flip that around now, I think.
yeah. That's
Well,
a
we want to,
great idea to do that.
well, let's just kind of rewrite this. Um, well, I can leave that stuff down below. We can clean it up in a second, but we're going to check if array.counts node equals node city or node. What am I doing? Just node capacity.
Yeah,
Um, then we're going to split the node. Array split node, which will take node pool and a node to split. Cursor.node. And then we're gonna, well, what we want to do is reassign cursor actually.
yeah,
So maybe just make it var. I think that's fine. And then say cursor. We'll just do the same thing again essentially.
yeah.
Because now the absolute index is going to go as a different cursor because if we've done split node, which invalidates cursors. And then we just assert that array.node that counts cursor node is less than node capacity. And then we don't need this check anymore. Say there's now enough space in the target node, or just get rid of the comment for now. And we've now just done this assert. So I guess do we want the count variable still? It won't
No,
hurt.
I think if we get rid of that, it's nicer.
Okay.
Yeah. Isaac, what I was thinking too is we could actually move the decision to split and reassigning the cursor. We can get rid of all of that and move it into split node itself. And we could then call it split node if necessary. And instead of passing a cursor, we just pass an absolute index. And then once we've split the node, if necessary, then we get a cursor just once and it's const.
Not sure about that yet. I guess that would avoid these repeated absolute cursor for absolute index calls.
Yeah.
These are not totally free because they have to iterate. Yeah. Um, Though that's tricky though, because um, yeah, this it's not clear like from the it's not clear which node of the two new nodes is going to have our absolute index actually. But we can determine that of course, but it's not just like super simple.
Okay.
Um,
Okay. Yeah.
you know what I
Because
mean?
yeah, because then
This
we
code is let's make sure this code's right first. I think
yeah,
it is now
yeah,
because we always just assume we have this assertion here that that this node has got capacity now.
yeah,
That's a valid assertion to make.
yeah,
And then we do the same thing that we did before, where we shift um, the data inside the node one to the right at the relative index we want to insert at. And then we assign the thing at the relative index to be our element, increment counts, and increment this thing for this node and all following nodes.
yeah,
Cool. That all seems great to me.
yeah,
Um, we don't have the count variable anymore. That's the only thing we've messed up.
yeah.
We can bring it back though. Const count equals.
I think yeah, we could, like we do for pointer.
Or we just get rid of it. But
Yeah,
I think it's kind of nice to have it.
yeah. We do
Um,
we do it already for pointer, and we do use count twice.
well, it's
So
only for these two places in this slice though. It's
yeah,
not like all that much.
yeah,
You don't use it after that. So maybe I should just put it in line here. I don't know.
yeah. Let's see. I think that's cool inline.
Well, let me do both of these. That's not bad, really. Let's
Yeah,
just do that. The pointer does make sense though, because it's kind of we have to like do this dereference, and it's a little bit messier.
yeah.
I feel like we use it again here too. Cool. This seems good to me. Okay, now let's figure out how we can. Because I also don't like these two separate calls to cursor for absolute index.
Yeah, and also what I was thinking is that because split node invalidates cursors, it's kind of nice if we pass an absolute index into split node instead, um, because that way we're kind of preventing the user from even having a cursor before they call
Yeah.
split node.
Well, right now we don't pass in any index at all. We just pass in a node.
Yeah. So split node, basically we call it like split node if necessary, and you passed in an absolute index, and that's going to figure out the node that's impacted and then split it. But then I guess the concern, like you said, is that how do we know then?
I think the split node compaction as we have it right now is a good function and it's a good level of abstraction.
Yeah,
I think if we do anything, we should instead add a second function on top of it, like
uh,
split node if necessary, instead of touching the current split node function.
okay,
But like kind of
yeah,
wrap it in another function. It
yeah,
doesn't need to be aware of indexes at all right now. Just
no,
takes a node and splits it. It doesn't care about any indexes,
yeah,
which
you're
I think
right.
is good.
Yeah, definitely.
Um, and so yeah, so I think um, yeah, we can do something tricky to avoid this call. You're right, because we can if we split it, then we know that we can see if this relative index is less than half and do that comparison. So I think let's do that. Let's put this inside a split node if necessary function.
Okay.
Um, um,
Oh, we can call it split node if full.
node, yeah, if full, and this returns. Um, it's also like it's very special case though for insertion though.
Mm,
It's almost like get insert index. Um, it's like we have insert empty node. Now it's insert empty element perhaps. Um,
yeah,
but it isn't quite. No,
yeah,
that's not right. Um, ensure ensure node capacity.
Yeah, that's cool.
Split node of fulls is fine, but it's more of like a descriptive name. It's kind of like telling about the mechanism, not the policy, or not like why it's doing it. I don't know. It's
Yeah.
not bad though.
Okay. I kind of think it could be policy because that's like segmented array. If a node is full, then you split it.
Okay. Yeah. But it's not really like
Yeah.
insert empty node doesn't really tell us how it does it. It
Yeah.
just gives us an empty node.
Yeah.
Um,
Yeah.
Whereas this kind of like makes you care about whether or not the node's full, even though you don't really care. All you want is actually to ensure that your node has space to insert.
Okay.
Um,
Okay.
Ensure node has space. Um, or ensure free space, something like that.
Uh,
Or
I like split node if full more because it tells you that
yeah,
it has side effects, whereas ensure node
right.
maybe sounds like an assertion or a verification check.
Okay, that makes sense. Yeah, naming things is so hard. Anyhow, I think let's roll with this for now and see if we're
Yeah.
happy with it.
Yeah.
Um, I think we may very well be. Pollute index U32 returns. It's going to return a cursor, right? Yeah. Uh,
Yeah. Segmented array
segmented
cursor.
array cursor. I feel like we should have a shorter name for this inside this file, but
I think so
it's kind of
too.
like we could.
I think we should call it cursor in this file, and outside where we import it, we should then call it segmented array cursor.
Yeah,
I don't know
we
what
could
you.
also like just do like here. Um, there's like yeah, const cursor equals segmented array cursor, not make this one pub.
Okay.
What do you think about that? Or just call it cursor here, and then import a segmented array cursor in the other ones. Because like then
Yeah,
it becomes
that's
if we do it like if we just rename this to cursor, then we have like in ManifestLevel, we then have segmented array cursor equals import segmented array dot cursor. You don't like match the names anymore,
yeah.
but maybe that's fine. Like
I
this,
think it's fine because it's coming from the segmented array namespace. The
yeah, I guess that's fine. Let's just do that.
yeah. Yeah.
Um, um, where are we now? What are you laughing at?
I was wondering if you hit a key binding thing there again.
Oh yeah.
Yeah.
I'm still fumbling around a little bit, but it's getting better. It'll
Yeah.
be gone by next week, hopefully.
Yeah. Cool.
um, yeah. I also like unnecessarily changed some other things. I may have changed too much at once, so then it just like it's like if you only change like one thing, then it only takes like a day to adapt usually.
Yeah.
But if you change like more things at once, then it takes a little bit longer.
Yeah.
Um,
Yeah.
so I also moved like my navigation, like my Vim keys. The Vim as it uses like HJKL as the directional motions, right?
Hmm.
Um, but that's actually not on the home row. That's like one to the left or some odd reason. Who knows? But that's like what I had muscle memory for before. That's like also what Cocoon uses by default. But
Yeah.
it actually makes more sense if it's like on the home row exactly instead of like having two directional keys for your like right index finger, like
Yeah.
H and J.
Yeah.
Instead usually like JKL semicolon instead. So I switched to that because it's actually more comfortable. But
Yeah.
I messed up muscle memory again there. um,
Yeah, it's like ceteris paribus rule, you know, ceteris paribus, like all
Ceteris paribus. I
things,
don't think I know that.
all other things being kept the same, and we change one thing, then this is what we
Yeah.
assume, you know, like ceteris paribus. Yeah.
Well, yeah, that'd be the ideal way to then adapt quicker, but
Yeah.
it's not bad. I'm already mostly adapted.
Yeah.
So we still need to do this cursor for absolute index thing once, but I think we can avoid doing it the second time. Let's say just like const cursor.
Yeah.
Let's try making it const. And here we should move the assert like up here perhaps.
I was just going to suggest
Or
that
just keep the assert
because
there.
I think it's better outside because then we're checking that that function does
Yeah.
what it should. It's like a cross check. Yeah.
Exactly. And so here we're kind of just going to say, I think, cursor. Oh. I guess we're going to do that, except we need to pass in the node pool as well if we're going to split nodes inside this.
Yep.
Node pool. Node pool. Okay. Getting there. We've got the right API now, and now we need to figure out how to do this. So we could use an early return now, perhaps, and just say if, yeah, flip this condition around.
Yeah.
Return cursor, but then also make this less than, and then we're going to assert they're equal. And now we're going to split the node, and then we need to figure out what to return.
Yeah. Nice.
Yeah, so I think we take our relative index that we had before and compare it to half. So then we have to kind of like leak half into this scope. I'm just gonna write something that's correct, and we can like talk about whether it's the right thing to do here or not. But what we do is we say if cursor.relative index is less than half, then we're just going to return essentially. We just return the same thing. We just return cursor. Otherwise, we're going to return a different cursor, which is going to be node equals cursor.node plus 1 and dot relative index equals cursor.relative index minus half. Okay, that's correct now. I'm pretty sure.
Yeah, Isaac, just to check, we could also just call cursor for absolute index again.
We could, yes, but it would be less efficient. This does iterate over nodes.
Yeah. It's not like we're not often going to split, and it's only when we I think maybe like safety wise, it might be nicer just to keep it simple and we just do cursor for absolute index again.
Sure. Yeah, I could see that. This is correct though.
Okay.
Like,
Okay. Yeah. Okay, cool. Well, we can leave it like this and just test it. Yeah.
Yeah. I'm
It,
pretty sure this is right. Yeah.
yeah.
I
Just
don't like the
because
fact that it happens here and here though. That's what I don't like
exact.
about it.
Yeah, me too. We're assuming the boundary for split node, and it feels
Hmm.
like a off by one is not like, not that it's there, but it's into that territory that it could be easy. Or so like what we
Yeah, it's
could,
definitely a place where you expect to see a bug pop up like 5 years in
yeah,
the future when someone refactors without knowledge.
exactly. Yeah,
Uh,
it's like quite tricky. So we could have split node return the cursor, um, and even make
but
the
you just then
dis
make split node aware of the index.
exactly
I think
which
if you're right, we should just use this until proven that it's not feasible from a performance perspective.
yeah,
We
yeah,
already wanted to do other optimizations here, so I think
yeah,
we should just keep it simple for now and just return
yeah,
that.
yeah.
Um,
And
and
this
say,
isn't
oh, look
like
at the comment
this,
thing. We could, yeah,
yeah. This isn't in the critical performance path. Like it's not really in the data plane. It
right, yeah. Insertion
happens.
isn't the hard part or the
No,
like expensive part. Yeah,
no.
just return. Splitting the node invalid cursor. We actually we could avoid here and instead use our to do in constant time, but this would is or this would be that would be much more error prone.
Yeah.
And is likely not, and the optimization is probably likely not worth it.
Yeah. Uh, or we could say, and because kind of saying the optimization is likely not worth it, then we invite someone to test it, or it,
Okay.
what we could say is, and the optimization does not affect the common, it does not affect the data plane. Uh, it does a little bit, but it's not. Yeah, it's not the common case. It's not
Um, we can also just say to do well
investigate.
we can just say period here and then
Yeah,
say to do we think that the optim and the that wouldn't be worthwhile as it doesn't affect the data plane
yeah,
enough.
that's it.
And is
Yeah,
that good?
yeah, that's cool. Uh, maybe we can do after the to do, we can do capital W over there. And then I think because basically when we do a compaction, we're going to create output tables. We're going to insert those tables into our um, level manifest.
Yep.
And most of the time, those inserts are going to go into nodes that have space. So most of the compactions are not going to be splitting the node. And so it's only
Right.
some compactions eventually when the node fills up, then we will, run into cursor for absolute index. So it's kind of like if we get it wrong, it'll sink the ship. And if we optimize it, we'll get a tiny, tiny bit of gain. Like we might, it's out of the data plane and it's kind of amortized even there. So yeah. And then I don't know what you think. Maybe we should just, okay, well we do obtain I think it makes sense that we return the cursor. That's what I was wondering. But we did.
Yeah. Then this becomes even simpler then. 'Cause we just have
Yeah,
to create a cursor and we
yeah,
assert that we've got space in the node,
yeah,
and then we just put the thing in there. That's pretty
yeah,
sweet.
yeah. Okay, and then uh, I'm just taking a look at the mem copy. So we going into the cursor relative index plus one. Uh, we're shifting everything by one to the right. Okay, looks like we've got a Discord disconnect. Hey Isaac, can you hear me now? I think we're back.
Oh, cool. Excellent.
Great.
Um, you just froze for me. I think that was on your end. I'm not sure.
Yeah, I think it
I
was
can
on
hear you,
mine.
but your video is still frozen. Um,
Is it still frozen?
your video is frozen for me. I'm not looking at the stream though. Let me look at the stream, I guess.
Okay.
Stream seems to be working for your video.
Yeah.
Um,
Yep. Yeah, I see you now. Hopefully you can see me.
yeah, your video is still frozen on mine. Just a second.
Okay.
Um, I don't know how to refresh this. Um,
Do you want to leave the call and then we'll go back in?
yeah, I'll just come back in, I guess. All right, see you
Okay.
in a second.
Cool.
All right, that seems to have worked.
Okay.
Um,
Yep.
cool.
We're back.
Screen share going again. Discord's done its funky stuff, but I think we're good to go.
Yeah.
Um,
There we
I'm
go.
ready.
Yep. Yeah, we all good. Yeah, I was just saying, I think we've got a bug because we update the absolute index of the current node, but that actually doesn't change. It's only subsequent nodes.
Oh, here? Yeah, I think you're
D.
right.
Yeah.
Yep. Good catch.
Cool. And if we are currently at the last node, then I think we might
Yes.
have a bounds check failure here as well if we do a +1.
We're fine actually, because we'll get a zero size slice then.
Okay.
Because array.node count would be then equal to the last node plus one, right?
Yeah. Oh, you know what? I think we should rewrite the slice also so that we do like a double slice.
Why so?
Uh, okay. Oh, basically, sorry. We wanna go to the end. Yeah, we want to go up to the last node.
Yep. Yep.
Uh, yeah. So then we'll get a zero size slice.
Yep. This is
Yeah.
this is now right with the plus one. Good catch though.
Cool.
That was just a logic bug.
Yeah.
Um,
Great. Uh, one other way to look for bugs in all this code is to check where we use bookkeeping helpers, and then to check what they depend on, because at some stages in here we're kind of like in twilight zone, where we've added an empty node, but it's undefined or um,
yeah, that makes sense, but I think that's only the case where we have undefined stuff like between um,
over
this
here.
copy and these are updates. Those are those are right next to each other.
Yeah,
And here in split node, it's between this insert empty node call and then these updates.
yeah.
So I
So
think we're safe on those things, but it's definitely a good place to watch out for.
yeah, yeah.
Um,
So once you're outside of split node, there's no more undefined data. We just have an
yep.
extra node, but all the data is valid and can be used. All the helpers are valid.
Yeah.
Uh,
And yeah, we after split node's done, yeah, it's again a totally valid list. The absolute indexes are unchanged.
yeah,
Um,
cool.
this is the where it leaves stuff undefined. So after you call this function, things are not valid until you fix them up.
Okay,
But that's we do that all inside split node.
yeah,
Um,
okay,
so yeah, that, that's all good. I think very good
yeah,
catch here though.
yeah,
Um,
cool.
pointer cursor relative index equals element read at counts cursor node plus equals one. Yep, this all seems very reasonable.
Yeah,
I think that's insert elements potentially done. How's this work? We've got nothing. We have no nodes. If it's an empty segmented array, I think you can't split nodes then.
yeah.
Um, if
So
there's
then we
no
need,
nodes in the pool.
yeah,
Should we just like initialize them always with a single node? I think that's the easiest way to solve that edge case. Um,
yeah. We do,
I think we do have to do that because like we've also accounted that for that in our calculations because we said we always have like the one extra node at the end that's not full or
yeah,
that's not at least half full.
yeah,
And
yeah.
so on initialization, we always claim one node per segmented array, and then we don't need any special case here.
Yeah. We could, we could also allow it and say it can be empty if that helps our static allocation.
I think that doesn't really, because I
It
think it's not a
doesn't.
big difference.
It, it
Yeah,
it actually it's required the +1 because it might
yeah.
only have one element. Uh,
In the last node, yeah.
yeah,
That can always happen no matter, that's not just a case at the beginning, that's a case like any time in the lifetime
yeah.
of this stuff.
Uh, in I think we do. Do we have code in here where we check if it's full or not? Uh,
The whole thing is full, or what do you mean?
sorry. Do we check? do we have cases where we check if the segmented array has 0 nodes? We don't ever think about that, eh?
No, we don't.
Okay. Okay.
I think we should always just allocate a single node on startup, and then
Yeah.
scared would work beautifully then. It
Yeah.
doesn't need any special key. So,
It
can we just
might.
write that real quick then?
Yeah.
Um,
Just before we do, it might boomerang because it helps us on the insert path, but when we remove, we'll try to get rid of nodes as well,
hmm.
if they're empty.
We just have one special case there that says,
Yeah.
um, yeah, we also don't account, do we handle empty nodes properly though? That means we'll have an empty node when we start up. And right now, we don't really assume that nodes can be empty, I don't think.
Exactly. Yeah. I think what we should just do here is above where we call split node if full, above that, just decide whether we want to insert an empty node or not.
Yeah, I think you're right. I think we should start without any empty nodes and handle empty nodes properly. So
Yeah.
we can remove down to 0. Because like we have
Because,
that check up above in, just as an example, in manifest level, we have like this in start, iterator start is what it is.
that's what I was thinking of. Yeah. Yeah.
Um, this one.
Yeah.
And so we already have precedent for that, and it made sense here, so it'll probably make sense in the rest of our code too.
Yeah.
Um,
Yeah. Cool. And also, Isaac, I was thinking because that way the segmented array becomes more usable elsewhere. Like if we don't, we can use it efficiently without it always requiring memory.
yeah, that makes sense. You also then won't waste, yeah. We'll still statically allocate our full node pool, but
Yeah.
yeah. So insert element. That means that if array.node count equals 0, then we're going to statically allocate. We're just going to say array.node count equals 1. Then what are we going to do? We're going to assign the pointer, the relative index, and the count.
Yeah.
Node. I'm trying to hard code 0 on these things. Do you think that's good?
Yeah.
Equals, well, it's mean node pool. And get node. Array.counts 0 equals 0, which we're then going to fix up here though. We do that with plus equals 1 though, so we still need to assign it to 0.
Yeah.
And array.relative or absolute first element. All right.
And then it
Does
makes
that
me
do it?
think, I think so. I think then what we should do is where we split the node, we shouldn't set to undefined. We should rather do exactly the same as we do here. And then and then elsewhere we just have assertions that check that in the middle of our segmented array or things like that, we can have a few checks that we don't have these just empty nodes somewhere.
Okay. Um, yeah, I'm not sure. I'm not totally convinced because we don't rely on the fact that these, where's our undefined stuff? We don't have to rely on these values. Like we're never going to try and read this value currently. And
Yeah.
so I hesitate to make that 0 unnecessarily because we're
Mm.
going to, maybe it's safer though. I don't know.
Yeah, that's what I think that we we're now allowing the concept of an empty node because it's
Yeah, and
both
so
these.
it's safer, it's more robust against misuse to just, um, well, actually, this can't be 0. This got to be the absolute index
Okay.
of the next node. Actually, we just don't touch that one, because it's already correct then.
Hmm.
You see why that is? We've copied, this is the absolute index of the node that used to be here.
Yeah.
But since this new node's empty, that's the same thing as the absolute index of the next node.
Yeah.
So it's actually the absolute index of the next node, but it's the same as the,
Yeah.
So we don't even touch this.
Yeah.
We should have a comment there, though.
Yeah.
The it actually is already correct as the there are no elements in the node. Therefore,
just another idea, what we could do here instead of a comment is just assert and say assert that the absolute index of this node is equal to the next node.
Yeah, that's better than a comment.
Yeah.
It is redundant, but it's then like in the code. It's harder to ignore.
Yeah.
And
it's just as long as a comment because we've got this long name.
yeah, equals. Okay, and this needs to get wrapped, I guess. There we go. Yeah. I'm liking this. This seems more robust. Should change this comment now. They're not left undefined. Well, we now have the concept of an empty node, so we can just leave it at that, I think.
Yeah, we can drop that. Yeah.
Insert empty node at index node. Yeah.
Nice.
Oh. Well, this now assumes that nodes are already present. It'd be nice if this worked if nodes weren't present as well. You know what I mean? Like if array node count was 0, this would still work.
Yeah.
Then we could just call here insert empty node. If array node count is 0, insert empty node, and then things would work.
And that's what we should do because we don't want to duplicate where we set the metadata. Yeah.
There would actually this wouldn't work then if we were doing it like that. And it might actually be too awkward to do that. I'm not sure because here we do copy like all the other nodes in the array, but actually these would all be 0-sized slices, right? Because the current node is 0, array.node count is 0, so this would be a 0-sized slice. And this would be out of bounds though.
Yeah.
That'd be the issue.
Yeah.
It would make this code a lot more complex. I think it's actually fine like this, to be honest.
Yeah, I think that method we should actually rename and say insert empty node after.
Yeah.
Or is it? Oh no, it's not. It's inserting it at.
Yeah. Yeah.
Insert
Before?
empty.
It's at, isn't it?
At that node index. That's what our comment has got.
Yeah, you're right.
I often find like sometimes I like we improve our function name and then we realize, oh, that's the comment had as well.
Yeah, I think we should also say that this does explicitly say that this requires asserts that the segmented array is not empty.
Yeah.
Or has at least one node.
Yeah.
It could have one empty node and it would still work fine, but it needs to have at least one node.
Yeah. Cool. So we can add that assert in here, like just to make
it's already technically present, but we can make it explicit.
Exactly.
We're redundant with it. There's no +1 already does assert that, but assert. We can do two things actually. We can assert node is less than array.node count, and assert array.node count is greater than 0.
Yeah, nice.
Good?
Yeah, that's cool. Just to make it explicit, even though we've got the
Yeah,
bounds.
yeah. So then this serves as documentation too. We might even get rid of this comment
Yeah,
now we have that.
yeah,
Because the code is even more powerful.
yeah.
All right. Now we're back up to here. Are we actually good here now? I think we are. And I think it's better to have this out here because then this is a special case. This
Yeah.
like wouldn't be able to do the assert if we had it in the same function.
Yeah.
And so this is good. That's good. That's good. That's good. Cool. And that's all we need to handle that. The rest of this works fine. We'll then see
Yeah.
that the node isn't full. We'll get the cursor to the first node. At absolute index, in this case, we probably should assert the absolute index as 0, right? Can we do
Yeah.
that? Does that make
Yeah.
sense?
Yep. That's a great check to have. Good idea. Good catch.
Yeah, because otherwise it wouldn't make any sense to insert.
Mm.
Yeah. Cool.
Do we check our absolute index? I think we do. When we turn it into a cursor, it will get checked.
Probably. You mean this?
Yeah. Cursor for absolute index.
I think we don't, but I think we should. I think we forgot to copy some asserts from down here. I think we
Yeah.
should. Yeah, we need this. This is the one.
Okay.
I can also grab. Yeah, this is the big one.
So that'll be the last absolute index of node count -1.
The last node. This could be written more idiomatically now, though. We could do array.last.node. Last gives us the last cursor.
Yeah.
Cool.
Nice. Oh, you know what?
The other one too, then. Yeah.
Yeah, cool. Yeah, that's a great idea. It's really nice. And then within last node, or within last,
Oops.
we're actually using node elements to take a slice.
Oh, well, we have last node already. What? Where did that come from? I think I just had this, but then forgot to delete it.
Yeah.
This one, you mean?
Yeah, that one we should
just use counts there, right?
Exactly. Yeah.
Yeah. -1. All right. Cool.
Do we still have references to last node, Isaac? That function
No,
that
I
we
don't think so.
discovered.
I think that was just something we had.
Okay.
Nope.
Okay. Okay. If you like, over here we could take a const to node count -1.
Sure. Man, I keep pressing the wrong key for that. That's what's going on.
Nice.
Still getting used to having shift on my middle fingers instead of my pinkies. That's like such a common thing you use.
Yeah.
I also have a shift key on my thumb now, which is kind of nice.
Nice. Cool.
Then you can like just hold. Then you don't need to worry about shifts switching hands with the shift when you type like normal sentences to like shift to
Yeah.
capital letters.
Yeah,
And, like
it makes
prose. Then it's pretty nice.
yeah,
Have just one shift key on your thumb. You can all just
Yeah.
hold it down. You don't even need
Yeah.
caps lock or anything. You just hold
Yeah.
the thumb.
Yeah. It's like you're playing bass guitar,
Oh yeah,
slaps.
you're slapping the bass.
Yeah, yeah,
All right,
cool.
that looks
Yeah,
good. That does make
yeah,
it cleaner too.
yeah. I really like how you're doing array last node. Uh, yeah,
Yeah, read it
that.
last and
Yeah.
notice. It just reads nicer, right?
Mm,
There's no need to think about why you're doing -1. It's you
yeah,
want the last note. That's like the idiomatic thing. And
yeah,
the same thing with this. Why we made this is because it reads nicer,
yeah,
which also just kind of does.
yeah.
Absolute index the first element. You know what? That's fine. We don't need to refactor this one. This one's fine. Um,
What were you thinking with
I was
that?
wondering if we could use like last relative index, but it doesn't really help. I don't think.
Yeah.
Um, it actually does. It's absolute index plus last relative index. No, it isn't. It's node relative index. Yeah, that doesn't
Yeah,
help. Never
yeah,
mind.
yeah.
Um,
It's for the actual node somewhere in the middle, maybe.
yeah. All right. Cool.
You know what I realized I don't know if it was over the holiday. I think it was like this last week, because we were saying that we were finding it quite tough, or I was saying especially that I find it compared to the consensus and replication. Um, I think the reason is the consensus is tricky in other ways because the consensus you can fix something or add a feature and it looks correct. And then if you examine it like with a few more chess moves, then it's checkmate.
Yeah.
Uh,
Like
that
if you remember that messages can be replayed, and then everything breaks. Or if you remember
exact.
that messages can just get dropped, then everything breaks.
Yeah, 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 yeah. And then, but what makes it easy is because it's just message passing, and there's no real like data structures or persistent stuff, and it doesn't really happen at big scale.
Yeah.
It doesn't have those elements. It's got very tricky like concurrency stuff. Like that's really tricky, but it doesn't
Yeah.
have.
I think that's the tricky part is just like the keeping all the concurrency stuff in your head and the
Yeah,
fault models.
yeah,
Um, it's
exactly.
definitely tricky in a different way though, you're right. Because like the
Yeah,
data structures are far simpler.
yeah,
Um,
yeah.
just
But
have a
the
few
but
like FIFOs and yeah.
exactly. But the LSM stuff, like here, you've got to do like quite like these. It's quite tough data structures, or not tough, but it's quite like. I mean, this is pretty tricky, getting it right, and the iterators, and
Yeah. I mean, just rolling your whole own LSM trees is a pretty big challenge.
yeah,
And then or then just end up just implementing custom data structures to support that work.
yeah,
Um, which I think is the right
and
thing to do. I mean, this does fit our use case perfectly.
yeah,
Um,
definitely, and also like the scale, like 100 terabytes with this LSM. Plus, we're trying to
yeah,
keep memory usage very efficient, static allocation. So it's like big scale, persistent stuff, like data structures. It's a
yeah,
it's a different kind of Everest.
it is. Yeah,
Yeah,
just writing code in a way such that allocation failure is handled properly, and
yeah,
all memory is allocated up front is just a different way of thinking about programming in some ways.
yeah,
You can't just there's no dynamically sized arrays anymore. Deal
yeah,
with it.
yeah. Yeah. I enjoy it though. It's quite nice. Yeah? Like, what do you find?
Oh yeah, I think it's really
Yeah,
fun.
yeah,
It's also just more robust.
yeah, yeah.
Yeah,
And you kind of helps us get to a nicer design, like where we've thought through everything that we know. Memory usage is fixed. It's not gonna grow unboundedly.
yeah,
It was a little bit hard, but now the design is better.
for sure. Yeah, I think yeah, we've got. I think insert's pretty much done now too.
Yeah,
All right.
cool. I thought what we could do if our node count equals 0 branch, where we assert on the absolute index, we could just add a new line after that, as if that's like the
Sure. Yeah.
precondition for that block. Uh, yeah,
And then, yep. this all seems good.
Yeah.
Should we just do a commit now? I think we've just finished the just insert function, and that
Yeah.
seems like a nice logical chunk to commit.
Yeah.
Um,
Yeah, great. We can add a new line there after that insert element function. After insert elements, we can add a new line.
oh yeah,
Yeah,
wonder what that happened to that.
cool.
Um, um, see if we see anything else we want to change before we write the commit. Just a bunch of new code, and then renamed cursor, got rid of last node, add another helper function, made some stuff cleaner, removed some dead code. That's not too messy. I think it's alright if we have slightly messy commits, but
Yeah.
just keeping it into logical chunks is good. And like this, the dead code we removed is also related to the code we're working on, so it's fine, I think.
Yep.
Or should this be like, should it still use the lsum prefix, or is this like segmented array? Insertion for sure.
We're probably going to move this out of LSM so that it's like a general data structure.
Yeah, so we should just be segmented array to implement insertion, maybe.
Yeah.
How's that?
Yep.
It's not really related to LSM trees anymore. It's now at lower level, for sure.
Yeah.
I think. Do you have any comments you want to add here? I think I'm kind of good with just having the code.
Just like that is good. Yeah.
Oops. Whoops. Sorry.
Do you want me to switch off the stream? Do I need to switch off the stream? Like when you sign in
I
your
can drag it
commit?
over to my other monitor. That's what I tried to do, but then I closed it by accident.
Okay. Okay, cool.
Sorry. Segmented array, implement insertion. Now it's gone.
Nice. Cool.
And we've succeeded. I'm typing my password. Cool.
Awesome. And no one is going to be able to use audio analysis on the keyboard because they don't know your layout.
They have no idea.
And it's constantly remapping, you know.
Yeah, it could be different tomorrow. And my password's
Yeah.
long enough and complex enough anyways that I don't think anyone could even brute force it with the limited knowledge they have.
Yeah. Yeah. Yeah,
Anyhow,
hey, like, you know, why change your password? You can just remap your keyboard.
but then like keep the password in the same keys. That'd be pretty funny if your password was like typing something in the wrong layout for the keyboard.
Yeah. Yeah.
That doesn't make any sense to the keys you're typing, but
Yeah.
you
It's
think
just the
about your
same.
keyboard differently, then it makes sense.
Yeah.
It's like a code on top of a code.
Yeah.
Anyhow,
Yeah.
what are we on to now? Is this the right API? I think it is. Absolute index.
Yeah.
Well, so there are some tricky things here we've managed with the index with the keys path, because we have these two things here that need to be kept in sync with the keys segmented array. And so when we split nodes inside the keys segmented array, we need to like also do stuff to these.
Yeah.
I just realized this.
Yeah. But that we're gonna do, that's kind of like our index metadata. So we're gonna, are we thinking we're gonna manipulate the table nodes segmented array or table segmented array? And then when we're done at the end, we're going to have a rebuild function that's going to go and rebuild keys, root table nodes array, root keys array.
No, it might actually be really good because you know what we can do then? We can kind of ensure that this segmented array is always like fully packed. Like there's no half full nodes. It could always be all full nodes all the way through, which then makes
Yeah.
querying faster, I think.
Okay.
Does it? Actually, it
I,
probably doesn't.
hmm.
Hard to say. Then what happens is you have fewer root nodes, um, and more keys in each key node. Yeah, I don't know what the right call is there.
So
I think incrementally rebuilding it might actually end up being, um, yeah. Hmm.
I think what we'll find is that if we manipulate tables, then it might get too tricky to try and rebalance keys and shift things and that. So I think it's better we treat tables as our canonical data source. So we go and after compaction, we'll
Yeah.
go and mutate tables. Tables is all correct because it's just a segmented array. And then once tables is done, we basically reset root keys array, reset root table nodes array, reset keys, and we rebuild keys from table and just the whole index layer on top. We just throw the old one away and create the new one.
Okay. And so, yeah, that works. I think you're right that the bookkeeping would be pretty tricky to go from tables to keys, and because we also have to keep these in sync, then it gets even trickier.
Yeah,
Because then it's not like confined to segmented array, but in this function instead.
yeah,
And so I think we might need like some kind of bulk insert function that like takes an iterator and then goes over, or like has a reentrant API or something that just fills up the whole thing in order without making half full nodes. Um, Otherwise, if you like just call our current insert function in a loop right now, you could do that to insert all the items, but what it will do is you'll end up with only half full nodes.
yeah,
And so that's not great, right?
yeah,
Because it'll fill up the first node until it's full, then it'll split it in half and you'll have two half full nodes.
yeah,
Then if you continue inserting items in order, which I think we will be doing, you'll then fill up the second node till it's full, then split that in half, then you'll have three half full nodes.
yeah,
And then fill up the third node till it's full, and split that in half and have four half full nodes. Because if you're always inserting in order, it'll only make new half full nodes.
yeah,
And so I think we need like a different mode where it instead makes full nodes.
yeah. Like a bulk insert mode for the segmented array.
Yeah.
We do kind of have that in the interface. We just haven't implemented it.
Yeah, but we also won't have a slice to pass in there. We're going to be inserting from based on the table segmented array. Um, what we have is an iterator.
Oh, you mean in compaction we've got an iterator?
Oh, well, for the tables we've got, yeah. So there's two separate things here. I'm talking, and you're right that for compaction we're going to be doing a bulk insert into tables. Then also if we then rebuild keys based on the data in tables, that's also like a bulk insert. Um, Rebuilding keys is like inserting all the elements in keys, right?
Yeah,
So I was trying to ensure that keys it doesn't use the worst case memory in all cases.
yeah,
Maybe that's fine though, because we have like planned for the worst case memory usage.
yeah.
Um,
We have, yeah.
Maybe there's no problem here. I'm just like I think worrying about nothing. And
But
I don't think it would actually be slower either because then we've got like more tiers essentially.
mm,
Um, we then use more. We then kind of just use more of the root node, and so we eliminate more keys with the first binary search in the root node, which may be better.
yeah, yeah. It will be. It might make like iterating a little bit slower because the table nodes are
Yeah,
half
it would
full.
definitely.
So
Yeah, you're right about that. But it won't be like crazy slow. It'll
no,
just be well, twice as many nodes. So there's two factors in the iteration. I think one's the number of elements, one's the number of nodes. And so the nodes factor will be twice as large as it could be in an optimally packed scenario.
yeah,
But I think that's not really that bad.
no,
We'll still have more than a cache line of elements in each node, or more than an effective cache line. Um,
yeah, exactly. Yeah. So I think like for safety, it's just nice to know we keep it simple. We rebuild our root and keys,
Yeah,
and it's not so expensive. We only do it at the end of compaction, and yeah,
yeah. So that works out then, I think.
yeah.
Um, cool.
Otherwise, if we did do the incremental rebuild, so just to check, what do we put into keys again? It's parallel. Hey, keys are the key mins of every table.
It's just the key min of every table in tables, yeah.
Yeah,
And so to build that, you can iterate over tables using our iterator, and for every table info you see, you then do an insert. You call then keys.insert key. Um,
yeah,
and then we need some kind of bookkeeping then to keep track of when to insert key mins. Or no, that we just do that all the way through. And at the end, we go, well, the root table nodes might be tricky. This one we might need to do during iteration somehow. I'm not sure. Um, I think we can do that though. What we do is we just check in our iterator if node count is increased by the insertion we do to keys. If node count is increased, if node count after the insert is greater than node count before the insert, then we put the current table node in this array at that node. Um,
yeah,
we can kind of just check what keys does, and then map if it increases the node count, then put that in here. And this
yeah,
one you can use the same strategy for. So
yeah,
this one you could also rebuild just after it's done. You just iterate over the nodes and keys and take the first element from each node.
yeah,
But we could also just do that during iteration if we're already doing it for this one.
yeah.
Um, I think that works then, yeah.
Okay, cool. So you mean actually the incremental rebuild is not so complicated?
No, it's actually pretty simple, I think. We have
Yeah.
already got an iterator for tables, and so well, no, that's not incremental. That's from scratch rebuild I was talking about. Um,
Okay, okay, okay. Because actually, like
incremental,
when we insert into tables, at the same time we're going to insert into keys because those two things are in sync.
yes. Maybe the incremental is not actually that bad. Um, the tricky part with incremental is keeping these things in sync.
Those two.
Um,
Yeah,
is when a node in keys is split, we then need to update these.
yeah,
Um,
yeah. And then and kind of we don't know that, then it complicates our split node stuff because we need like callbacks and things too.
yeah. Um, and you can do that you can kind of observe the side effect of calling keys.insert
Mm.
by checking the node count before and after the insert call.
Yeah.
Um,
It
but
could get
still, you
tricky
don't really
though.
know which node was new.
Exactly,
Yeah,
because if we're gonna add in like our
not a good way to
fixer,
do it.
if we're gonna add our fixer uppers in to like merge stuff as we insert, we don't really know, like you say, which node changed. Uh, sorry, Isaac, can you hear me?
Um,
Okay, I
yeah, I can hear you.
sorry, lost your audio there.
Oh,
It's, yeah,
I probably just moved too far away from my mic. Um,
yeah,
it's really not
yeah,
a person mic. It's an instrument mic.
yeah, yeah. Cool. So, okay, so we're going to just rebuild from scratch our root stuff. Keys and tables, we do the inserts at the
Yeah,
same time. And then we can also start to close the loop quicker. And these like rebuilding root
yeah,
from scratch is not it's not in the data plane really. So yeah,
yeah. And this stuff is also easy to refactor or optimize down the line too. So there's no on-disk
yeah,
representation that would be broken by changing this code to make it more optimal.
yeah,
It's just optimizing the algorithms, which
yeah.
is it's definitely the easiest thing to change.
Okay.
So yeah. So what do we have left to do then? We've got insert already. Do we just now? Well, I'm not really quite clear on what the call from compaction will look like. Will compaction give us an iterator of tables, or just like call it with a table every now and then, or just a slice?
I
Do
think
we?
if we go look at our compaction, I think we're actually going to have a fixed array where we're going to store the table infos that get created.
Really?
As we output a table info, we just need to, probably got a to do where we've just finished creating a new table and we get a table info out of that. There's one thing we need to do here too
Right.
is we need to split this compaction tick into two so that we separate the IO and the CPU. So I was thinking we could call it tick IO and tick CPU. So
Yeah.
the forest tick is going to call tick IO on all the trees. Then it's going to submit to IOU ring, and then it's going to go tick CPU on all the trees.
Oh, I see. Yeah, that makes sense.
Yeah,
Otherwise, it only that definitely makes more sense.
yeah, because we have
It's gonna be a little
to.
bit tricky though, I think. We'll
Yeah,
see. So it's compaction, it's merge, it's tech CPU that will then cause the tables to be done.
yeah.
Here's our to do. Yep. It says we may need to wait until the table has been fully written to disk or until the compaction finishes.
Mm.
Um, can the compaction fail? Writing to disk can fail for sure. Um,
Writing to disk, the way it fails though is we pick up the failure later.
right.
So
We just kind of panic and yeah.
writing to disk almost always succeeds. Otherwise, we panic. And if it really fails silently, we'll pick it up when we try to read and then handle it.
Right.
Uh,
So that's
so
fine.
here it's just
And we won't
it,
we won't write the manifest to disk anyways until the compaction's done.
yeah. Here, whether we put the info in the manifest now or whether we batch it and then put it in, it's just a question also of side effects. So if we make it visible in the manifest, is it going to then influence the rest of the compaction that happens? That's my one question here, you know.
Yeah, that makes sense. Maybe the simplest thing is probably to store it until the compaction's done. I
Yeah,
think that'd be the safest thing to do here, just intuitively.
yeah,
Um, we've also
yeah,
got an upper limit on how many infos we can create, right?
yeah,
We've got to have, because we have an upper limit on the inputs, so there must be an upper limit on the outputs too.
yeah,
So we can just make an array at the right size and store the infos there till we're done.
yeah.
Um,
And also because it's incremental compaction, uh, the compaction will tick and then it will yield and then we'll run some user operation. So we might not want that manifest to be visible to the user until so basically we want to do the compaction. All the compaction does is just copying stuff to disk. It's like copy on write. So we're going to copy to
yeah,
disk. The user is going to carry on reading from the original copy. And then right at the end of compaction, we want to atomically swap in and change the manifest. Okay, so that makes sense. So we actually can't update the manifest because then we have to already call rebuild.
yeah. I want to call
Uh,
that at the end, but I think we also don't have a bounded number of tables because it's an incremental, and we've got a bounded number of like iterators, but it's not a bounded number of tables that can be produced here. At least not. Um, it's a very high bound, at least. It's like something like the whole number of tables. Um,
the
maybe it is.
It isn't. It's actually the growth factor. So
Yeah,
level,
I just realized that too.
yeah,
Yeah,
it's level A times the max growth factor.
and we combine tables from level A with level tables from level B. Isn't it like plus the number of tables in level B that overlap with the tables in level A then? Um, we're rewriting those tables.
Yeah,
We also need to delete tables as part of the compaction too. We've
yeah,
got to
that,
like queue up a bunch of deletes and new tables
yeah,
to be done all at once at the end.
at the end, yeah. Basically, all the inputs to the compaction will get removed. So and we've already got them stored here. So all the level A and level B table infos.
Well, we've got the iterators, but we don't have the table info stored yet, I don't think.
Yeah,
Yeah, it seems like it's bounded here for sure.
yeah.
Um,
If you take
well,
one table, then there'll be 10 tables in the next level. And if none of the 11 tables overlap, then you'll read, you'll have one table plus 10, and then you'll end up outputting maximum of 11 tables. Yeah.
yep, that makes sense. And so
And
we also need to store the tables we want to delete though, and
yeah,
then kind of like do all the deletions and creations in one batch on the manifest in memory,
yeah,
and then rebuild the
rebuild.
manifest keys and root stuff, and then we're done with the compaction.
Yeah,
Um,
yeah. We can actually keep keys and tables in sync because they parallel segmented arrays. So if we remove a table info, we can just remove the corresponding key min from keys. It's always one for one.
yeah.
Yeah. So
Um, the tricky part is those root things though, because they still correspond to keys. And so if you remove, or you're adding to keys and you cause a node to be split, now you need to update these things.
yeah. So
But the
those
code in segmented array isn't aware of these things.
no. So those two things are those are the things we're going to throw away and rebuild. But the keys and
Okay.
tables, those two segmented
Oh,
arrays, we can keep those in sync.
okay, that seems reasonable.
Yeah.
Um, how do you rebuild these two things? For the keys array, it's really simple.
Easy.
You just iterate over over the pointers and take the first element from each pointer,
Yeah.
assuming the pointers aren't empty. And we can also assert that none of the pointers are empty except for the last one, maybe.
Yeah.
Um,
And then we just
I
have
think,
to map each of those root keys into the corresponding table node. So we have to
right?
basically do
And
a
then
ON linear scan over tables to keep matching them to the root keys.
actually isn't do this. This won't do any compare keys. This is just about absolute indexes. Um,
Yeah,
it is an ON scan over both the tables and the keys
that's
nodes. That's
exactly.
just looking at the absolute indexes of each node.
Yeah,
And so yeah, that's actually not very expensive. That's slightly tricky, but it's not bad at all. And so
yeah,
you're right. We don't need to ever throw away keys. I like that a lot better too. 'Cause that
yeah,
just like lets the segmented array do its thing instead of wiping it and replacing it with old half full nodes every now and then.
yeah,
Um,
yeah. Cool. So yeah, and those top two things should be pretty simple and maybe it'll be faster because there's
rebuild.
much less branching. We just let the CPU sprint to the 100 meter without zigzagging, and it's done. Uh,
Yeah.
then like incremental will be a lot of like if, whereas the bulk learning is just let's just go for it, and then
Yeah.
the
Well, I think this will be faster than rebuilding keys from scratch for sure.
yeah,
Um,
yeah,
and this stuff would definitely be is definitely faster to just rebuild from scratch, I think, because
yeah,
it's also way simpler because then we don't need to dirty up our segmented array abstraction. And
yeah,
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 that seems like the
exactly.
perfect way forward.
Nice. And I think we're never going to come and optimize that or change it. It's just that's the
No,
right
I don't
decision
think so.
because there's too much safety risk as well. But,
Well,
yeah. I've got another 5 minutes or so, and then I need to head
all
off.
right,
Uh,
cool.
but
What do we want to do for 5 minutes then? Should we like plan out what we want to do tomorrow? We could do that.
yeah, yeah, we could. I think first up in segmented array, we want to do remove. We could. Do you
Right.
want to
Yeah.
like by planning out? Shall we jot down like to dos in our like in a
Sure. You just like stick them up here maybe, or
yeah, yeah,
to the top of segmented array. Okay.
yeah,
Let's do it here. To do um,
uh,
remove or
yeah, remove. Then we want to do. We can even just implement remove just below the to do. Then we can have a whole lot of stuff there. Then we want
sure.
to, when we insert stuff, we want to maybe add that optimization, not to split a node, but maybe we don't even want to worry about that. Maybe it's just simple is better, you know?
I think we just leave that off for now and just
Yeah,
come back to it if we need to.
yeah.
Um, because we
We
do
want,
have, I think it's not even that useful, I don't think. It
no,
saves like one small copy, a relatively small copy on insert. It doesn't make querying faster. It doesn't, we have already accounted for that memory, so we're okay with using that much memory. Um, so
and it actually
it's
makes the
not clear
common,
that it really get us much.
yeah, the common case becomes slower because now we're checking if we need to do the edge case.
They're very
Uh,
slightly slower. It probably is like faster on average on insert, to be
yeah,
honest, but I think it
yeah,
doesn't really matter that much. Um,
cool. Then we want to be able to shrink, like we want to be able to merge nodes if they become half full, which we're going to see when we do remove. We want to do unit
yeah,
tests for segmented array already. And I think that's all. And then we want to go and plug it into compaction. Uh, in compaction, we want to track tables as they are from the iterators. The
um, uh, action, track tables during,
removed.
yeah,
We want to do unit tests for segmented array. And we also want to do level 0 uh, level manifest.
sorry, manifest levels, what we called it.
Yeah, manifest level.
Cool.
And I was wondering maybe we can think about it, but maybe within manifest level we want to do a switch there so that we can use the same type across all levels and the user doesn't have to worry about level 0 anymore.
Hmm. I feel like yeah, I'm not totally convinced. I feel like
Okay.
that's implementation like this fact that level 0's got overlapping. It's not something manifest level needs to care about. That's like something of the
Yeah.
It's something that LSM3 is aware of, not the manifest level data structure.
Yeah.
Um, we can also rename it to be not manifest level and just call it like non-overlapping level, um,
Yeah.
or something like that.
Or we can say manifest level non-overlapping or manifest level disjoint.
Or just manifest level and call it level 0 manifest level overlapping.
Yeah. Yeah,
Um,
that's cool.
something like that.
So what I thought is we could also make it like an enum literal that you take for the type instead of giving it
Yeah,
different
I think
type names.
there's no reason. Yeah, I think there's no reason to make this type care about it though, because it's
Okay.
just a separate type. Like there's no
Okay.
real reason.
Yeah.
To do it.
What I thought it will help with is when we do compaction, when we do range queries, we always going to be going down through the whole tree. So that way
Yeah,
we'll only
but
have a single type across levels. We
we
won't have.
won't though because it's two separate types. If you generic over something, you're gonna get two separate types.
I didn't think to make it generic. I thought we actually have a runtime switch according
Oh,
to the level.
runtime check. Oh,
Yeah, yeah,
I see now. Okay.
yeah. So that just so
And
that
so,
every
well,
level we just use the same type
we
and
don't need to do that inside manifest level potentially though. We could also do that runtime check inside manifest, which we haven't really talked about yet at all, and just have a
okay,
mapping or just a single branch there in manifest that says
yeah,
if the query level equals 0, use the special level 0 code. Otherwise, index into this array of manifest levels with
that's it.
the query. I think that's the way to do it.
Yeah, I think so.
Um,
I think so too. Because we actually need a
because we don't, yeah,
manifest to tie it all together. Yeah,
yeah,
cool.
we do that in there,
Yeah.
overlapping tables.
And maybe, I don't know, maybe do you want to do the compaction stuff after we've got manifest all done? And then
Maybe, probably, as long as we're not sure, as we are sure that we won't hit like any showstoppers there. I think we won't.
okay, okay.
Um, I mean, it probably wouldn't be bad to figure out how that works. It's like they're pretty connected. So
Yeah, so then we go plug it into compaction as soon as possible, and then we go and do level 0 and type the manifest and everything.
yeah,
Yeah.
level 0 also is kind of just special though.
Yeah.
Maybe because we also know that we need that for sure. So maybe it's not. Yeah, I'm not sure what the right order is here, but I think these are definitely all things we need to get done pretty soon.
Yeah.
And these are all like any one of these would make sense to do next, I think.
Yeah.
Well, these two are kind of together.
I
Um,
think I think we should do the
other than
tests
that,
and finish segmented array fully with tests and everything.
yeah.
Then we go plug it in and yeah.
And then these two are unknown order.
Yeah. I
Um,
think then it comes down to what we're excited about, you know. Yeah.
yeah,
Yeah.
these are just not numbered.
Yeah. Cool. Maybe, you know, like when we plug it into compaction, we'll also feel good because we know we've closed the loop and then we keep
Yeah,
going.
yeah.
Yeah.
And then we'll have like the actual whole. Yeah, I think that'd definitely be good.
Yeah.
And so plugging into compaction though, I think also involves making the manifest abstraction. Compaction won't talk directly to a manifest level. It will talk to the manifest as a whole. So I think that actually
Yeah.
does need to come later,
Yeah.
after we get level 0 figured out. And yeah,
Yeah. We can always do manifest without level 0 and do everything else for compaction and then go and
just have
do
a
this.
panic or just a to do assert when you hit when you try and use level 0.
Yeah.
Um,
Yeah. Cool. Yeah, I can't wait to get this thing up and running. It's going to be so cool.
yeah,
Maybe we're getting closer now. Like once we get manifest finished, get compaction
yeah.
finished.
We also need to
Yeah.
write manifests to disks, manifests to disk. I think we have a strategy for that
Yeah.
already though,
Yeah.
which actually won't be too bad with how we've got this laid out now.
No.
Um,
No.
especially with
Yeah.
how we solve snapshots. That's gonna make things so much nicer.
Yeah.
Um,
Yeah. It's gets pretty simple like after this, I think.
and
Hopefully.
now so we've kind of just got our data laid out in a it's a very linear format. It's got snapshots all in the same array. We just need to, what we need to separate is the levels, I guess. So we need to
Yeah.
figure out how to um, represent the different levels on disk. But other than that, it's just one manifest per LSM tree.
Yeah.
There's still some stuff to take into account there, but it's not too bad, I don't think.
Yeah.
Um,
Yeah. We've got to do like super block on disk, like you say, representing the level also of a table. Uh, yeah, it'll be like lots of odds and ends, but hopefully we can just fly through that. Uh,
yeah,
yeah, awesome.
cool.
Yeah, yeah. So shall I sign us off, and then we'll be back on same time
Sure.
tomorrow. Yeah. So
Yeah,
Tiger Beetle
9 o'clock
sessions.
tomorrow.
Yeah, yeah, 9 o'clock. And it's 8 a.m. UTC. Yeah. So Tiger Wheel sessions, 24 January, session 9. Thanks everybody for dropping by. Really fun. And catch you tomorrow.